Earlier in the course, you learned a little bit about objects. You learned that objects are collections of key value pairs. So if we have properties that are highly related, we want to encapsulate them inside of an object. Here's an example. Let's say we're building an application for drawing different kinds of shapes, like circles, rectangles, and so on. So we could declare multiple variables around circles. For example, radius, we set that to 1, then x and y. We're defining multiple variables, but all these variables are highly related. They represent a circle. A better approach is to put these variables inside of an object. Now we can send that object anywhere in our program. We can pass that to any functions, and all these variables will be available in that object. So I'm going to define an object. We could use let or const. In this case, it doesn't really matter. So let's define a circle object using the object literal syntax. So we add these curly braces, and inside them we add one or more key value pairs. So the first key is radius, and the value is 1. Now this value we have here can be any type in JavaScript. It can be a number, a string, a boolean, null, undefined. It can even be another object or an array or a function. Let me show you. So instead of defining two other key value pairs as x and y, I'm going to add a key called location and set its value to another object. Now in this object we can have two key value pairs or properties. The first one is x and the second one is y. We can also have another property here like is visible and set that to a boolean, true or false. Okay? So the purpose of an object is to group related variables. But it's not just grouping related variables. Quite often we have functions that should operate on these variables. For example, we can have a function like draw for drawing a circle, or we could have another function for moving a circle, right? So again, these functions are highly related to these variables we have defined here. So instead of defining these functions in a standalone way, it's better to put these functions inside of the circle object. Again, with this, wherever we have a circle object in our program, we have access to all its properties and functions. So let me show you how to add this draw function inside of the circle object. We add another key value pair. The key is draw, and the value is a function. So I told you that the value of a key value pair can be anything in JavaScript. Here, the value is a function. Now for simplicity, I just want to do a console.log here. Let's log draw on the console. So now with this circle object, we no longer need these independent variables and functions. All of these are now part of a circle object. So we can access them using the dot notation, circle dot. Look, all of them are here. We can simply call this draw function like this. And if I save the changes, you see the draw message here. Now, what you see here is what we refer to as object-oriented style of programming. So object-oriented programming, also abbreviated as OOP. Object-oriented programming is basically a style of programming where we see a program as a collection of objects that talk to each other to perform some functionality. So here we have a circle object, and this object has a few properties and a function. In object-oriented programming terms, if a function is part of an object, we call that function a method. So here, more accurately, instead of saying we're calling the draw function of the circle object, we say we're calling the draw method of the circle object. Okay, so draw method. So that's the difference between a function and a method. If a function is part of an object, in object-oriented programming terms, we refer to that function as a method. Now, using this object literal syntax is an easy way to create an object, but as our applications get more complex, we need a different way to create objects. And that's what you're going to learn next. In the last lecture, you learned how to use the object literal syntax to create an object. But there is a tiny problem here. Imagine we want to create two circle objects. So I'm going to copy this code here and call this second circle object circle2. Now the problem we have here is that we have duplicated the implementation of the draw method. So right now it's a simple method. It has only a single line of code. But what if we had 10 lines of code here? We wouldn't want to repeat all these lines here, because if we have a bug in this method, then we would have to fix it in multiple places. And also take into account that our circle object currently has only a single method. What if we had 10 other methods here? We don't want to duplicate or repeat all that logic, right? So if our objects have logic, we need a different way to create objects. That's when we use factory or constructor functions. In this lecture, you're going to learn about factory functions, and we'll look at constructor functions next. So I'm going to delete this second circle and show you how to create a factory function. So factory function. Just like a factory producing products, these factory functions produce objects. So we define a function and call it create circle. Now we're going to move this definition of the circle object inside of our factory function. So we have a circle object here. Finally, we need to return this. Now, one way is to return it like this, but we don't really need this circle constant defined because we are not going to reference it anywhere. We only want to return it. So we can make this code shorter by removing the circle constant and simply returning this object. So whenever we call the create circle function, we'll get a circle object. However, we have hard-coded these values here. So every circle that is created by this function, its radius will be 1. That's not what we want. Maybe we want to have a circle with a bigger radius. So we want to pass radius as a parameter here. So radius. And then instead of hard coding 1, we want to set the value to this radius argument that we supply when calling this function. Similarly, we can add another parameter here like location. And instead of hard coding this object here, we can simply set location to this location argument. However, for simplicity, I'm going to remove these two properties, location and is visible, so we can focus on the core of factory functions. So let's delete these properties. We don't need the location parameter either. Now we can make this code a little bit shorter. So in modern JavaScript, if our key and value are the same, we can make our code shorter by removing the value and simply adding the key. So that is exactly equivalent to this code, right? So that is better. Next, we have our draw method. There is also a shorter syntax to define this method. So instead of defining it as a key value pair, we can define it like this. So draw, parentheses, and a code block. This is similar to how we define a function outside of an object, right? So if you want to define a function, this is how we define it, right? So we have the function keyword, then the name of the function, parentheses, and code block. Now, when we put this inside of an object, basically we're dropping the function keyword and simply adding this inside of the object. You can see this syntax is a little bit shorter than what we have here. So let me delete this and move this console.log statement in our draw method. So now we have a factory function. We can simply call this to create a circle object. So I'm going to define this constant circle1 and call the create circle function and pass 1 as the radius. Now let's log this circle object on the console. Circle1, save the changes. So you can see radius is set to 1. We also have this draw method. So we can call circle1.draw, and here's our draw message on the console. Now the beauty of this factory function is that we have defined our logic in one place. So we can call this function with different values or different arguments. We get different circle objects, but we have defined the draw method only in one place. So if there is a bug in this method that we need to fix in the future, there is a single place that we need to modify. So now I'm going to create another circle object, circle2, create circle. I'm going to pass 2 as the radius. Let's log this on the console, circle2, save the changes. Look, we have 2 different circle objects and a single definition of the draw method. So this is all about factory functions. But factory functions are not the only way to create objects. We can also use constructor functions, and that's what you're going to learn next. In this lecture, you're going to learn about another pattern for creating objects. That is a constructor function. So just like the factory function, we're going to create a function, and the job of this function is to construct or create an object. However, the naming convention we use for constructor functions is different. So the naming convention we have for factory functions is what we call camel notation. So the first letter of the first word is lowercase, but the first letter of every word after is uppercase. This is what we call camel notation. So it looks like this. Camel notation. We've got 1, 2, 3, 4. You can see the first letter of the first word is lowercase. And these uppercase letters look like camel humps. That's why we call it camel notation. In contrast, we have another notation that is called Pascal notation. And in this notation, the first letter of every word should be uppercase. So 1, 2, 3, 4. You can see the pattern, right? Now, when naming constructor functions, we should use Pascal notation by convention, because that's something that other JavaScript developers expect when they read your code. So we're going to call this function circle with a capital C. Note that I did not call this create circle, and you will see that in a second. Now, just like our factory function, here we need to add a parameter, radius. However, instead of returning an object, we're going to use a different approach to initialize an object. In JavaScript, we have a keyword called this. And this is a reference to the object that is executing this piece of code. You're going to see that in a second. For now, just imagine this references an empty object. Now, you know that with dot notation, we can access properties of an object, we can read a property, or we can set a property. So on this new empty object, we want to add a property called radius, and we set that to this radius argument that we receive here. So in JavaScript, our objects are dynamic. Once we create them, we can always add additional properties or methods to them. So here we're adding a new property to an empty object. Now, similarly, we're going to use this approach to add a draw method to this new empty object. So this.draw, but we set this to a function. And in the body of this function, we simply do a console.log of draw. Now finally, in order to create a circle object using this constructor function, we're going to define a constant called circle. And here we're going to use another keyword that is new circle and pass 1 as the radius. What is happening here? Well, when we use this new operator here, 3 things happen. This new operator creates an empty JavaScript object. Something like this, constant x set to an empty object. That is happening under the hood, but you don't see that. Next, it will set this to point to this new empty object. So in this code, we have access to this new empty object, and we set this radius property as well as the draw method in this new object. Finally, this new operator will return this new object from this function. So it looks like this, return this. We don't have to explicitly add this statement here in this function. This will happen under the hood. So let me recap. When we use the new operator, 3 things happen. This operator first creates an empty object, then it will set this to point to this object, and finally it will return that object from this function. So what we get here is that new object, and we simply set circle to point to that object. Now let's see the difference between factory and constructor functions. So with factory functions, we create an object like this. Constant, my circle, here we call create circle and pass an argument. So with factory functions, we simply call a function, and in this function we return a new object. In contrast, with constructor functions, we use the new operator, and instead of returning an object, we use the this keyword. Also, in terms of naming convention, with constructor functions, we use the Pascal naming convention. But in factory functions, we use the camel notation. So you might be asking which approach or which pattern you should use to create new objects. Both these patterns are equally good for creating new objects. The constructor function pattern is familiar to developers who have some experience programming in languages like C# or Java. So with this pattern, you can see we're creating a new circle. Now, if you don't have any experience in languages like C# or Java, you might want to go for a factory function. There is really no difference between these two patterns. However, there are some discussions online by some strongly opinionated developers comparing these two patterns. My suggestion to you is do not get hung up on these discussions. They're just a waste of time. Pick one pattern and just stick to that. One thing you need to understand about objects in JavaScript is that they are dynamic, which means once you create them, you can always add new properties or methods or remove existing ones. So here we have a circle object with a single property that is radius. We can add another property like color, set it to yellow. Now, when we log the circle on the console, you can see we have two properties, color and radius. Similarly, we can add a new method here, circle.draw. We set it to a new function. And now, when we log this on the console, you can see our circle object has three members, two properties, color and radius, and one method. We can also delete existing properties or methods. So here, before logging the circle, we can use the delete operator to delete a member from a circle object. That member can be a property or a method. So circle.color. We can also delete the draw method, so circle.draw. Now save the changes. You can see now our circle object has only the radius property that we added at the time of creating this object. Now, something that some developers find confusing is that here we have used the const keyword to define a new constant. However, you can see I have modified the circle object. I've added a property and then removed that property. So what kind of constant that is? Well, when we use constant here, that means we cannot reassign this variable. So this variable is more accurately a constant. So we cannot reset circle to a new object. If we do that, we get this error, assignment to constant variable. So we cannot reassign this constant, but we can always change the circle object by adding or removing properties. Every object in JavaScript has a property called constructor, and that references the function that was used to construct or create that object. So here we have two objects, circle and another. Let's look at the constructor property. So here on the console, another dot constructor. So as you see, this returns our circle function that we used to create this object. Now let's look at circle dot constructor. What is this? Well, you can tell that this is a function because here we have this blue F. And as you can see, the first letter of this function is uppercase. So this is a built-in constructor function in JavaScript. When we create an object using the object literal syntax, internally, the JavaScript engine uses this constructor function. Let me show you. So I'm going to temporarily delete all this code. Let's define an object like this. When we use this syntax, object literal, JavaScript engine will translate that to something like this. Let x equals new object. Okay, so this circle object, we created and returned it from our factory function. And because we use the object literal syntax, internally it was created using this object constructor function. In JavaScript, we have a few other built-in constructors. For example, we have string for creating strings, but quite often we use string literals. So single quote or double quote or backtick. Using these literals is cleaner and simpler than using the constructor. We also have Boolean, but again, we don't use this. We either use true or false. So we refer to these as Boolean literals. We also have number, but instead we use number literals, like 1, 2, 3, whatever. So this is what I want you to take away. Every object has a constructor property, and that references the function that was used to create that object. One of the confusing concepts in JavaScript is that here functions are objects. So this circle function we have here is actually an object. Don't believe me? Let me show you. So circle dot, look, these are all the members of this circle function or circle object. So the purple icons are methods like call, bind, and apply, and the blue icons are properties. So let's take a look at a few of these members in the console. Here in the console, circle dot name, that returns the name of this function. Circle dot length returns the number of arguments. Now earlier in the last lecture, I told you that every object in JavaScript has a constructor property, and that references the function that was used to create that object. Now here's the interesting part. Who do you think created this object? Let's have a look. So circle dot constructor. So here we have another built-in constructor called function. And when we declare a function using this syntax, internally, JavaScript engine will use this function constructor to create this object. Let me show you. So I'm going to define a constant called circle1 to separate from our circle. Set it to new function. Now here our function requires one parameter, radius. So we add that here as a string. Now as the second argument, I'm going to pass the code inside of this function. So to break it up into multiple lines, I'm going to use the backtick character and then simply copy all this code and put it here. So when we declare a function internally, it's represented like this. Now we can call this circle1 just like calling our circle function. So we can create a circle object by newing up circle1 and pass 1 as the radius. Save the changes. Now in the console, let's log circle. Look, it's a real circle object with these two members. Now let's take a look at a couple of methods that are available in our functions. So I'm going to delete all this code. Circle dot. Here we have this call method. And with this, we can call a function. Look at the arguments. The first argument is this argument. Here we need to pass an empty object, and this will reference this object that we pass here. Okay? Now after that, we add our arguments explicitly. So here we have one argument, we pass 1. If we had multiple arguments, we would pass them explicitly like this. Okay? So this expression is exactly like expression on line 11. When we use the new operator, this new operator will internally create an empty object and pass that as the first argument to the call method. And this object will determine the context for this. So this will reference this object. Earlier, I told you that if you don't use the new operator, this by default will point to the global object, which is window. So if I want to rewrite this expression in this way, instead of passing an empty object, I would pass window. Of course, we don't want to do this. I'm just explaining to you what happens under the hood. So Let's revert this back. So the first argument here specifies the target of this. Okay. Now we have another method called apply. It's exactly like the call method. With this, we can call a function, but instead of passing all the arguments explicitly, we pass them in an array. So this is useful if you already have an array somewhere else in your application and you want to pass that array as the second argument to the apply method. So this is the takeaway. In JavaScript, functions are objects. In JavaScript, we have two categories of types. On one side, we have value types, also called primitives. On the other side, we have reference types. So in the value types category, we have number, string, boolean, symbol, which is new in ES6. We're going to look at that later in the course, as well as undefined and null. These are the primitive or value types. On the other side, we have objects, functions, and arrays. So in the last lecture, you learned that functions are also objects. The same is true about arrays. So in a nutshell, in JavaScript, we have primitives and objects. Now in this lecture, I'm going to show you how primitives and objects behave differently, because this is absolutely important for you to understand before we move on to the next section where I talk about prototypes. So on this empty canvas, I'm going to define two primitives, x and y. I'm going to set y to x. So here y is 10. Now I'm going to change the value of x to 20. What I want you to note here is that x and y are two independent variables. So let's save the changes, go back in the console. Let's log x is 20, and y is 10. They are independent. So when we work with primitives, this value that we have here is stored inside of this variable. When we copy that variable, that value that is stored in the variable is copied into this new variable. So they are completely independent of each other. Now let's see what happens if we use a reference type or an object here. So I'm going to change this to an object that has a property called value. And then instead of setting x to 20, I'm going to set x.value to 20. So save the changes. Back in the console, let's log x. So you can see value property is 20. Now let's log y. You can see the value property of y is also 20. So this is the takeaway. When we use an object, that object is not stored in this variable. That object is stored somewhere else in the memory, and the address of that memory location is stored inside that variable. So then when we copy x into y, it's the address or the reference that is copied. In other words, both x and y are pointing to the same object in memory. And when we modify that object using either x or y, the changes are immediately visible to the other variable. So here's the conclusion. Primitives are copied by value. Reference types or objects are copied by the reference. Let's take a look at another example. So I'm going to define a function called increase that takes a number, and here we simply increase this number by 1. Let's declare a number variable and set it to 10, and then call increase and pass this number. Now, if I log this number on the console, what do you think we're going to see? Let's have a look. So save the changes. We see 10. But didn't we increase the number? Well, when we call increase and pass this number variable, its value is copied into this parameter that is local in this function. So this number variable here is completely independent of this other number variable. Here in this function, we increment number by 1, so it will be 11. But after this function, this number is going to go out of the scope. So when we log this number on the console, we're essentially dealing with this first number. So I told you that primitives are copied by their value. So here we're dealing with two independent copies. That's why we see 10 on the console. Now let's change this to a reference type or an object. So I'm going to change 10 to an object that has a value property. Okay, let's rename this variable to object. And similarly, I'm going to rename this parameter in this function to object, and then increment object.value. Now, when we log this on the console, what do you think we're going to see? We're going to see 11. See? We got this object with value 11. The reason for this is because when we call increase and pass this object is passed by its reference. So this local parameter that we have here will point to the same object that we defined here. So in this case, we are not dealing with two independent copies. We have two variables that are pointing to the same object. So any changes we make to this object will be visible to the other variable. So remember this. In JavaScript, we have value types, also called primitives, as well as reference types, which are objects. Our primitives are number, string, boolean, symbol, undefined, and null. Primitives or value types are copied by their value. Reference types or objects are copied by their reference. So here we have this circle object with the radius property and the draw method. Earlier in the course, you learned how to use the for in and for of loops to iterate over the properties in an object. So in this lecture, I'm going to review this one more time to make sure you fully understand how everything works. So first, let's take a look at the for in loop. For let key in circle. With this, we can iterate over all the properties and methods of an object. Now we can log the key on the console. So we have radius and draw. And if you want to get the value of a property, we use the bracket notation here. So as the second argument here, we pass circle of key. So we're using the bracket notation to get the value of this key or this property. Save the changes. So you can see the value of radius is 1 and the value of draw is a function. And here's the implementation of our draw function or draw method. Now we also have this new for of loop. Let's take a look. So for let key of circle, we simply log it on the console. Now when I save the changes, we're going to see an error. Circle is not iterable. So earlier I told you that the for of loop can only be used with iterables such as arrays and maps. You have not learned about maps yet. We're going to look at them later in the course. What you need to know is that an object is not iterable. So we cannot iterate it using a for of loop. However, we have this method object.keys of circle. With this, we can get all the keys in our circle object, and this will return an array. And since arrays are iterable, we can use the for of loop to iterate them. Now save the changes. Again, we get radius and draw. Now let's take a closer look at this method here. So earlier you learned that this object is a built-in constructor function. So somewhere we have this constructor function like this. And whenever we create an object using the object literal syntax, internally, that is translated into a call to this constructor function. So when we create an object using the object literal syntax like this, value is 1, internally, that is translated to a call to this object constructor function. So that looks like this, new object, right? Also, you learned that all functions in JavaScript are objects. So they have properties and methods that we can access using the dot notation. So when we type object dot, you can see all the properties and methods defined in this object. So here we're using the keys method, and this method returns a string array which contains all the properties and methods in this object. We have another similar method to object.keys. Let me duplicate this That other method is called entries. So instead of returning the keys as a string array, it returns each key value pair as an array. Let me show you. So let's rename key to entry. And to do that, we can press F2 to rename all the references to this key variable. Let's change that to entry. You can see that is updated here as well. Save the changes. So you can see each entry is an array. The first element in this array is the key, and the second element is the value. So that is also another way to get access to all the properties and methods in an object. And finally, sometimes you want to see if a given object has a given property or method. To do that, you can use the in operator. Here's an example. If radius as a string in circle would display a message like yes. With the in operator, you can see if a given property exists in a given object. Let's save the changes so we get yes here. But if I change radius to, let's say, color, we are not going to see the yes message now. Save the changes, yes disappeared. So the simplest way to enumerate the properties in an object is using the for in loop, but we can also use the for of loop along with object.keys and object.entries. And finally, to see if a given property or method exists in an object, we use the in operator. In the last lecture, you learned how to enumerate the properties of an object. Now, using this technique, we can get all the properties in an object and copy them into another object. So let's say we want to create another circle object, which is a copy of the circle object here. I'm going to call that another. So constant, another. Initially, we set it to an empty object. Now we can use the for in loop to iterate over all the properties in this object and copy them into this new object. So for let key in circle. Now we use the bracket notation to access a property with the given key. So we set another of key to circle of key. So basically here in the first iteration, key will be radius. So this code will be equivalent to this. Another of radius. So we're setting the radius property of another object to circle of radius. Now here on the right side of the assignment operator, we are reading the radius property of the circle. The value of this property is 1. So we'll get 1 and put it in the radius property of the another object. Okay. Now let's log another on the console. Save the changes. So here we have this radius property is set to 1. And here's our draw method. So if we call another.draw, everything works as we expect. Beautiful. But this approach for copying or cloning an object is a little bit old. In modern JavaScript, we have better ways to achieve the same thing. One way is to use the object.assign method. Let me show you. So I'm going to comment out these few lines. We have this object that you have seen before. This object has a method called assign. Now here as the first argument, we can pass a target object, which can be an empty object or an existing object. You will see the difference in a second. And then we can pass one or more source objects. Let's say circle. What this method does is that it takes all the properties and methods in this source object and then copies them into this new object and finally returns the result here. So this line of code is exactly equivalent to these 3 lines. If we save the changes, we get the exact same result. Now this target object that we pass here doesn't have to be an empty object. It can be an existing object. It can have one or more properties or methods. So as an example, let's add a color property here. We set that to yellow. Now save the changes. So this new object has the color property that we initially had here, as well as the members of the circle object. So this is the object.assign method. Now let me revert this back to an empty object. I'm going to show you yet another simpler and more elegant way to clone an object. We can use the spread operator. So here we set this to a new object, and then use the spread operator, which is 3 dots, to spread this circle object. Basically, what this operator does is that it takes all the properties and methods in this object and puts them here, in between these curly braces. So this is the simplest way to clone an object. Save the changes. Again, we get the exact same circle object as before. So here's what I want you to take away. Object.assign copies the properties and methods from one or more source objects into a target object, and we can use that to clone an object or combine multiple objects into a single object. And the spread operator is used to spread an object, which basically means getting all its properties and methods and putting them into another object. In low-level languages like C or C++, when creating an object, we need to allocate memory to it, and when we're done, we have to deallocate memory. But in JavaScript, we don't have this concept. We can easily create a new object. At the time we initialize this object, the memory is automatically allocated to this object. Next, we can use that. And when we're done using, we don't have to deallocate the memory. So our JavaScript engine has what we call a garbage collector. The job of this garbage collector is to find the variables or constants that are no longer used and then deallocate the memory that was allocated to them earlier. So you as a JavaScript developer do not have to worry about this. Memory allocation and deallocation happens automatically behind the scene, and you have no control over that. You cannot tell garbage collector when to run and what variables to remove from the memory. So based on some complex algorithms, this garbage collector runs in the background. It figures out what variables are not used, and then it will automatically deallocate their memory. So you have learned a lot about objects. Now let's take a look at a few of the built-in objects in JavaScript. The first one we're going to look at is the math object. So here in Google, let's search for JavaScript math. The first link is on developer.mozilla.org. This is your first reference for learning about all the objects in JavaScript. So let's take a look at the math object. We can see this is one of the built-in objects with properties and methods for mathematical constants and functions. So if you scroll down, you can see the properties. For example, one of the useful properties is math.pi. So this is the pi number. We have a bunch of other properties here, and below them we've got all the methods. The first one is absolute, which returns the absolute value of a number. So if you give it a negative number, it returns its positive value. So there are a lot of methods here. I'm not going to go through each of them. It's really a waste of your time and my time. All I want you to know is that we've got this math object built into JavaScript. So in your applications, if you ever have to deal with mathematical calculations, just come back to this page and see what methods you can use. In this lecture, I'm going to give you a quick demo of a couple of these methods. The first one is the random method. So let's take a look. For each of these methods, we have a comprehensive documentation along with examples. Really, really easy. So here in the console, let's call the random method. So every time we call this method, we get a new random number between 0 to 1. Now, if you want to map this to a given range, you need a simple mathematical formula. Back to the documentation for the random method. If you scroll down in the list of examples, we can see this example, getting a random number between two values. So basically, you need a function like this that takes a min and max and generates a random number between these two values. Pretty self-explanatory, you don't need more explanation. Another useful method is math.round. So we can give it 1.9 and it returns 2. We also have math.max. We can give it a bunch of arguments and it will return the largest number in the list. Now later in the course, this is going to be one of your exercises. So you're going to write a function like the max method here that takes a varying number of arguments and returns the largest value. We also have math.min, which returns the smallest number in this list. So I leave it up to you to look at all the other methods available in the math object. The second built-in object we're going to look at is the string object. So I'm going to define a constant message and set it to a string. Now look at this message dot. What's going on here? It looks like we have a bunch of properties and methods. But early in the course, I told you that string is a primitive type. Primitive types don't have properties and methods. Only objects do. So why is it that we see these properties and methods in this string? Well, the reason for this is because in JavaScript, we have two kinds of strings. So this is what we call a string primitive, but we also have a string object. So we have this constructor function string, and we can use that to create a new string object. So we can pass the same string here. Now, because this is a constructor function, we need to apply the new operator. And now we have another string. Now let's take a look at the type of each of these constants. So type of message, that's a string, but type of another is an object. So the first constant is a string primitive. The second one is an object. However, when we use the dot notation with a string primitive, JavaScript engine internally wraps this with a string object. We don't see that, but we can work with this like a string object. Now, just like the math object, if you want to learn about all these methods, it's best to look at the documentation. So simply search for JavaScript string. Once again, on developer.mozilla.org. On this page, you can see all the properties and methods of the string object. In this lecture, I'm going to show you a few of these methods, but I strongly recommend you to look at the documentation once, just have a quick look to see what methods are there in case you need them. So back to our code, let's change this string to this is my first message. Here we have the length property, which returns the number of characters in the string. This is particularly useful in situations where you want to make sure the user types at least certain number of characters in an input field. Or maybe you want to put a limit. You don't want the user to type in more than 100 characters. Now, if you want to access a character at a given index, you can use square brackets. So message of 0 returns T, message of 1 returns H. If you want to see this string has a special word, you can use the includes method. So does this string have my? Yes, it does, but it doesn't have not. We also have another method starts with. So this string starts with this, but if you pass a capital T here, we get false. So note that these searchers are case sensitive. We have a similar method ends with, so message.ends with E. So you can see the last character here is E. If you want to find the index of a given character or a given string inside the string, you can use the index of method. So let's see what is the index of my. So my starts at index 8. We can also replace a part of a string. So replace, let's say we want to replace first with second. Pretty easy. Note that this returns a new string and does not modify the original one. So if we log the original one, we still have, this is my first message. We also have a couple useful methods to uppercase. Once again, this returns a new string where all characters are uppercase. Similar to this method, we have to lowercase. And another useful method is trim. So let me add a couple of white spaces here before and after our message. Now, if we call the trim method, it gets rid of all the white space before and after our message. And of course, this method has variations. For example, we have trim left, which only removes the white space at the beginning of the string. We have trim right, and so on. Another important concept you need to know in JavaScript is escape notation. So if you look at the documentation for the string object, you can see in this table under escape notation, we've got these special characters. So if you want to use these, you need to encode them using the escape notation. For example, let's say you want to have a single quote in your string. Now in this example, we have defined the string with a single quote. So if you want to have a single quote inside of the string, look, our JavaScript engine gets confused because it thinks this second single quote represents the end of the string. To fix this, we need to prefix this with a backslash. And now this character is escaped, it's encoded. So when we log the message, you can see the single quote is actually part of the string. Another useful escape character is \n, which represents a new line. So back here, if we add a \n after my, this will add a new line. So save the changes. Let's look at message on the console. You can see we have a new line here. Another very useful method is the split method. So message.split. With this, we can split a string based on a given character. So here I'm going to pass a white space and see what we get. We get an array of 5 items, and each item in this array is a word in our message. Next, we're going to look at template literals. In the last lecture, you learned that \n adds a new line to a string. Now, what I don't like about this approach is that it doesn't allow us to visualize what the output looks like. In other words, if we log message on the console, you can see this is what the output looks like. So on the first line, we have this is my, and on the second line, we have first message. But when writing code, our string looks different. Now, if we want to make this string similar to what the output looks like, we have to do something like this. So we break this string into 2 parts and concatenate them like this. And then we add the second part on a new line. We can also put the first part on a new line. And now this kind of looks similar to what we have in the output. But we still have this \n getting in the way, creating some noise in the code. To make the matter worse, if we want to surround first with single quotes, we'll have to escape the single quote character like this. Again, this is very, very ugly. Let's log this one more time. Very, very ugly and noisy. That's where template literals come in the picture. So far you have learned about different kinds of literals in JavaScript. So we have object literals, which are indicated by curly braces. We have Boolean literals, which are true or false. We have string literals, which are indicated by single or double quotes. Now, starting from ES6, we have template literals, which are indicated by the backtick character. This backtick character is the character before number 1 on your keyboard. So let's see how template literals help us write cleaner code. I'm going to define another constant, but this time I'm going to use a template literal instead of a string literal. So we add the backtick character. This is my. Now to add a new line, we don't need \n here. We can simply add a line break and then type first message. So we can format our string the way we want it to look like. So now let's log message and another. See, what we have in code looks very similar to what we have in the output. Now we can also put this on a new line. Now, if we want to surround first with single quotes, we can simply add them here. There is no need to escape them because we have used a different character to define our string. So save the changes one more time. Message, another. They look identical, but compare this code with the former code. This is particularly useful if you want to send out email messages in your application. For example, let's say you want to send an email to the user like this. Hi, John. Thank you for joining my mailing list. Regards, Mosh. So we can format our string exactly the way we want it to look like. There is no need for any of these plus or \n characters. So let me delete all this stuff. Now, another benefit of using template literals is that here we can add placeholders. So let's say we want to add the name dynamically. With a regular string, we'll have to do something like this. So message, we set it to hi, then we have to concatenate this with some variable or constant. Let me define name here, set it to John. Now we'll have to concatenate this message with name, then add a comma, then \n. This is really, really ugly. Let me show you a better way. With template literals, we can add a placeholder using a $sign and curly braces. Now, inside these curly braces, we add an expression. We can pass the name of a variable or a constant. Now, let's save the changes. Let's take a look at another. You can see we've got John here dynamically. So this is a placeholder for our name constant. Now here we can add any kind of expression. We can also add a simple mathematical expression like this. Let's log this one more time. So, hi John 5. So technically, we can add any expression that produces a value in between the curly braces. We can also call a function that returns a value, and that's perfectly valid. So these are the benefits of using template literals. And finally, the last built-in object we're going to look at in this section is the date object. Now, just to clarify, the objects that we have looked at in this section, they're not the only built-in objects in JavaScript. There is more, and you're going to learn about them as we go through the course. So let's see different ways to create a date object. We can create date1, set it to new date. So date is a constructor function. Now, when we open parentheses here, you can see this number here, 2 of 6. That shows different versions of this date constructor. You can use the up and down arrows to cycle through these. So we can use the date constructor without any parameters, and this returns the current date time. So let's rename this to now. Let's create another date object, new date. We have another constructor with one parameter called value, which can be a string or a number, which is the number of milliseconds from January 1st, 1970, or another date object. So here I'm going to pass a string, let's say May 11, 2018, 9 a.m. Now this format is not the only format that you can pass here. If you want to find about all possible formats that are supported, simply search for JavaScript date on this page. If you scroll down, here under date string, you can read about various formats that are supported. And finally, another way to create a date object is by passing numbers. So here we have another constructor with these parameters. Year, which is a number, month is also a number, and so on. So I'm going to pass 2018. Now the confusing thing about these date objects is that month is 0 based. So 0 represents January and 11 represents December. So we're going to use 4 for May. The third parameter is the date parameter, and that's the day of the month. So 11. Next parameter is hours, so 9 a.m. and minutes is 0. Now we can exclude this argument because all the other arguments are initialized to 0 by default. So this is how we create a date object. Now all these date objects have a bunch of get and set methods. For example, now.get. So get date returns the day of the month, get full year, get hours, milliseconds, minutes, and so on. We also have set methods. So let's call set full year and change the year to 2017. We also have set date, hours, milliseconds, minutes, and so on, right? Now, let's see how we can display these on the console. So save the changes. All these date objects have a few methods for converting them to a string. We can call toDateString, and we get a string like this. So Thursday, May 11. Note that we changed the year on line 6. We also have toTime string, which returns the time component of this data object. Another useful method is toISO string, which returns a string like this. So we have the date, then t, and time. This is a standard ISO format and is commonly used in web applications. So if you're building a web or a mobile app that talks to a backend, this is the format you commonly use to transfer data between the client and the server. All right, here's your first exercise for this section. I want you to create an address object with 3 properties: street, city, and zip code. When you do that, then create a function called showAddress that takes an address object and displays all the properties in this object along with their value. So pause the video. When you're done, come back, continue watching. So now I'm going to create an address object. We can use the let or constant keyword. In this case, it doesn't really matter. Here we're using the object literal syntax to initialize this object. So we have a street property. We set that to some value. It doesn't really matter. Next is the city property. And finally, zip code. Next, we need to create this function, showAddress, that takes an address object. And here to enumerate the properties of this object, we're going to use the for-in loop. So let key in address, then we do a console.log of key and address of key. So here we're using the bracket notation to get the value of the given key. And finally, we call this function showAddress and pass our address object. Save the changes, and here's the result. So in the last exercise, we used the object literal syntax to initialize an address object. In this exercise, I want you to initialize an address object first using a factory function and then using a constructor function. So your exercise is to write 2 different functions. One is a factory function, the other is a constructor function to initialize an address object. So go ahead, and when you're done, come back, continue watching. All right, first I'm going to do the factory function. So factory functions simply return a new object. Here we can call this function createAddress. We should give it 3 parameters: street, city, and zip code. And here we simply return a new object with 3 properties: street, which we set to the street argument we receive. Now, as I told you before, if key and value are the same, we can make our code cleaner by dropping the value. So in this object, we're going to have these 3 properties. That's it. So that's our factory function. And we can simply create a new address like this. So instead of using the object literal syntax, we call createAddress and give it these 3 values. Now let's log the address on the console to make sure everything is working. Okay, here we have a new object with these 3 properties. Beautiful. Now let's write the constructor function. So constructor function. As I told you before, constructor functions have a different naming convention. So instead of camel notation that we use in factory functions, here we use Pascal notation. So the first letter of the first word should be capital. So we're going to call this function address. Again, we're going to pass 3 parameters. Now here, instead of returning an object, we're going to use the this keyword to initialize this new object. So this.street, we set that to the street argument, then this.city, and finally this.zip code. Now, to create a new address object using this constructor function, here we use the new operator and call our constructor function. Once again, we pass these values and log this address object on the console. So save the changes and we get the exact same object. So the purpose of this exercise was to help you get familiar with the syntax for creating factory and constructor functions. In the next exercise, we're going to look at object equality. In this exercise, we're going to use the constructor function that we created in the last exercise to create two address objects. So here's the first object. I'm going to call this address1. Now, I'm going to duplicate this line to create another address, but we're going to call this address2. Now, in this exercise, I want you to create two functions. One is called r=, so we pass two address objects, address1 and address2, and we check to see if these two objects are equal. Now, as I told you before, objects are reference types, so we can have two objects with the exact same properties, but these objects are in different memory locations. So when we use the equality operator, we're essentially checking to see if these objects have the same reference. Now, to properly check to see if two objects are equal, we need to check their properties. We need to make sure that all their properties are equal. So that's the job of this function, r=. If all the properties of these two objects are equal, this function should return true, otherwise it should return false. Now the other function I want you to write is r_same, address1 and address2. And this function simply tells us if address1 and address2 are pointing to the exact same object. In other words, they're referencing the same object. So go ahead and implement these two functions. When you're done, come back, continue watching. All right, I'm going to start by implementing the second function because that's easier. So to check to see if two variables are referencing the same object, use the strict equality operator. So return address1 equals address2. So if they are referencing the same object, we'll return true, otherwise we'll return false. Now with the other function, we need to check individual properties. So here we need to return a Boolean that is the result of evaluation of three conditional statements. So address1 dot street should be equal to address2 dot street. Here we use the logical AND. Next we add address1 dot city. This should also equal address2 dot city. Once again, we use the logical AND, and finally address1 dot zip code should equal address2 dot zip code. Now let's call these functions and see the results. So I'm going to do a console.log, call r=, pass address1 and address2, and then I'm going to duplicate this and change r= to r_same. Save the changes. All right, I made a mistake here, so here we should use address2. Save the changes. So you can see these two objects are equal, their individual properties are equal, but they're not the same objects. There are two different objects in memory. In contrast, if we declare another variable here, let's say address3, and we set that to address1. Now both these variables are pointing or referencing the same object in memory. So if we call r_same and pass address1 and address3, we're going to get true because they're pointing to the same object in memory. In the next exercise, we're going to work with blog post objects. In this exercise, I want you to create a blog post object with these properties: title, body, author, views, which represents the number of times this post has been viewed, comments. Now each comment should have a couple properties: author and body. And finally, another property that each post should have is live. That can be either true or false. So once again, you should use the object literal syntax to create and initialize a blog post. give each property some value. The actual value doesn't really matter. I just want you to get comfortable with the object literal syntax. All right, here's the solution. So let's create a post object using the object literal syntax. We set the title to A, body to B, author to C. So all these three properties are strings. Now views should be a number. We can set that to 10. Comments should be an array because we can have multiple comments. So we set that to an array. Now each comment should have two properties. So each comment should be an object. So here, once again, we use the object literal syntax to initialize a comment object. We set the author to A and body to B. We can have another comment in this array. Let's duplicate that with different values. And finally, we should add the isLive property. So isLive, we set that to true. And then let's do a console.log of post. Inspect this on the console. So you can see the comments property is an array with two objects. If we expand this, you can see the properties of each object. We've got author and body. In this exercise, once again, we're going to use a constructor function to create a post object. But this constructor function is a little bit different from the constructor function you wrote in an earlier exercise. So here's the scenario. Imagine we're building a blogging engine. The user is drafting a post, but they have not published it yet. What do you think that constructor function should look like? So spend a couple minutes on this exercise. When you're done, come back, continue watching. All right, let's start by creating this constructor function. We're going to call that post and note the capital P here. Now, what parameters do we need here? Well, obviously we need the title and the body and the author, but we don't need the number of views because the first time we create a post, views should be set to 0. And every time we view that post, we increment that value. So views is not something that we want to pass here. We want to use a default value of 0 when initializing this post object. The same is true for the comments property. For a new post that has not been published yet, we don't have any comments. So we don't want to add a comments parameter here. The same is true for the isLive property. We want to set this to false by default, so there is really no need to add an extra parameter in this function. So you should aim to have functions with fewer parameters. The more parameters a function has, the harder it gets to use it, okay? So here, we're going to set this, the title, to the title argument. The same is true for the body property and author. Now, for the views, I'm going to initialize this to 0. Similarly, we're going to initialize comments to an empty array. So in the future, we can add new objects to this array. And finally, we set isLive to false. Now, instead of initializing this post object here, we're going to call our constructor function, pass the title, body, and author. And finally, let's log this on the console. So you can see author, body, and title properties are initialized based on the values that we passed here, but the other properties have default values. So comments is initialized to an empty array, isLive is false, and views is 0. And finally, the last exercise for this section. Here on Yelp.com, we have these price range buttons. So we've got inexpensive, moderate, pricey, and so on. If you want to implement this concept using objects, what properties do you think those objects should have? That's the focus of this exercise. So I want you to create an array of objects. Each object is what we call a price range object. It's one of these objects here. Now here we have 4 price range objects. In this exercise, you can create only 3 price range objects. Think about the properties that each object should have. So pause the video, spend a couple of minutes on this exercise, and when you're done, come back, see my solution. All right, I'm going to create an array called price ranges. In this array, we're going to have 3 objects. Each object should have 4 properties. One is the label that we display to the user, like a $sign. The second property is a tooltip. So here, when I hover my mouse over each button, you can see a tooltip. So for each price range object, we need this tooltip property. Let's call this inexpensive. Now we need 2 more properties, and with this we can determine the minimum and maximum price of a meal per person. We can call them min per person and max per person. So for this object, I'm assuming that the average price of a meal per person falls between $0 to $10. And this is important for filtering, because if you're building an application like Yelp, somewhere we need to store the list of restaurants. So we might have another array here, restaurants. In this array, we're going to have restaurant objects, and each restaurant object should have this property, average per person. Let's say the average per person is $5. Now, when it comes to filtering, let's imagine that the user only wants to see inexpensive restaurants. So this is the object that we're going to work with. And in this object, we can see the price per person is between $0 to $10. Now, we want to filter the list of restaurants and pull out those where their average price per person is between these values. So that's the whole point of having these 2 properties, okay? Now, similarly, we can create 2 more objects. We just need to change the value of these properties. So here we have the moderate price range. Let's say that's between $11 to $20. And finally, the last one is going to be expensive, with price per person from $21 to, let's say, $50. So I hope you successfully completed this exercise. If not, don't worry. There are a million examples out there for you to practice. Whenever you're using an application, look at the features of that application, look at the concept, and imagine if you wanted to model one of those concepts using an object, what properties would you put in that object? The more you practice this, the easier it becomes. And that brings us to the end of this section. I hope you enjoyed this section, and thank you for watching. In this section, we're going to take a detailed look at arrays. You're going to learn all kinds of operations that you can perform on arrays, such as adding new elements to an array, finding elements, removing them, splitting and combining arrays, and so on. These operations are extremely important in programming, especially if you are starting out. So make sure to watch every lecture and do the exercises that I have designed for you at the end of this section. So now, let's get started. All right, let's start by declaring a constant called numbers. And we set this to an array with 2 elements, 3 and 4. Now, note that here, I've declared numbers as a constant. That means we cannot reassign numbers to something else. If we do this, we get this error, assignment to constant variable. However, it's perfectly fine to modify the content of this array. We can add new elements or remove existing elements. So constant does not stop us from modifying the content of an array, okay? So earlier you have learned that arrays are objects. So using the dot notation, we can look at all the properties and methods defined in arrays. In this lecture, we're going to look at 3 of these methods to add new elements to the end, beginning, or middle of an array. The first method we're going to use is the push method. So numbers dot push. We can pass 1 or more arguments, and these arguments will be placed at the end of this array. So I'm going to pass 5 and 6. Now let's do a console log of numbers. Save the changes. So we had 3 and 4. Now we have 5 and 6 at the end. If you want to add elements to the beginning of an array, you use the unshift method. Let me show you. So numbers dot unshift. This basically pushes the elements in this array to the right and adds new elements at the beginning. So again, here we can pass one or more arguments. I'm going to pass 1 and 2. Now let's bring this console.log down. And by the way, to do this, you can hold down the Alt key and press the up or down arrow. That's a good tip to know, okay? So save the changes. Now we have 1 and 2 at the beginning of this array. And finally, if you want to add elements to the end of an array, you use the splice method. So let's bring this down. Numbers.splice. With this method, we can go to a given position and add new elements or remove existing elements. Later in this section, we're going to look at removing elements. So for now, don't worry about that. Now look at the parameters of this method. The first parameter is start, which is a number. So that's our starting position. So let's say in this array, after 1 and 2 here, between 2 and 3, we want to add a new element. So our starting position is here. What is the index of this element? Well, you know that arrays are 0 indexed. So the index of the first element is 0, then 1, and here's 2. So our starting position or starting index is 2. Now look at the second parameter here. That's delete count, which is a number. How many elements do we want to delete? In this lecture, none. So I'm going to pass 0. And then look at the third parameter. That's the items we want to add. So to make this stand out, I'm going to add 2 characters here, A and B. Save the changes. So note that A and B are placed after 1 and 2. All right, now let's see how we can find elements in an array. Finding elements really depends if we are storing primitive or reference types in an array. So I'm going to start with primitives because they're easier, and then I'll show you how to find reference types in an array. So let's say we have an array of numbers with 4 elements, 1, 2, 3, 4. Here we have a method called index of. We pass the element we are looking for, and if that element exists in the array, this method will return the index of that element in the array. If it doesn't exist, it will return -1. Let me show you a few different examples. So first I'm going to pass the character A. Obviously we don't have this element, so the result that we will see will be -1. Look, so index of returns the index of the given element in this array. However, if I change this to 1, we get 0 because the index of this element is 0. Note that the type of this element matters. So if I pass 1 as a string here, again, we get -1 because we don't have 1 as a string in this array. We have it as a number, okay? Now, similar to index of, we have another method called last index of. And that will return the last index of the given element or -1 if it doesn't exist. So to demonstrate this, I'm going to add another 1 here. Now, let's do another console.log numbers dot last index of 1. Save the changes. So the last index of 1 is 3 because it's here, and the index of this element is 3, okay? So basically, to see if a given element exists in an array, we can do something like this. Console.log numbers.index of 1 is not -1. If this expression returns true, that means this element exists in the array. Let's have a look, save the changes. We've got true here. But this is a little bit ugly. We have a new method in JavaScript for achieving the same thing. So console.log numbers.includes 1. This simply returns true if the given element exists in the array. Let's have a look. So save the changes and we get true here. Now, all these methods have a second parameter, which is optional, and that is the starting index. For example, with index of, let's change this to 1 as a number. So save the changes. You can see the index of 1 is 0 because it's here, right? However, I can pass a second argument here. That argument is called from index. And that's the index at which the search will begin. So I can pass 2 here. So that is 0, 1, 2. Our search will begin here. Let's see what we get. Save the changes. So we get 3, which is the index of the second one in this array. In the last lecture, I told you that finding primitives is different from finding reference types. So let's see why. I'm going to start by declaring a new array called courses. And in this array, we're going to have a couple of course objects. So here's the first one with 2 properties, ID and name. The name doesn't really matter. Now we can duplicate this line by holding down Shift, Alt, and the down arrow. So let's change these values, ID 2 and name B. And don't forget the semicolon here. So we have 2 course objects here. Let's see if we have a course with the name A in this array. The includes method that you learned in the last lecture will not help us here. Now, let me show you. So courses dot includes. Here we pass the object that we're looking for. So course with the ID 1 and name A. Now, let's log this on the console. Console.log. Save the changes. We get false. The reason for this is because these 2 objects, that is the object that we're passing to the includes method, and the object that we have in the courses array, these are 2 different objects. They have 2 different references. They're in 2 different locations in memory. And in the last section, you learned that objects are reference types. So when we check them for their equality, the references are checked. In this case, there are 2 different references. That's why we get false. So if you have an array with reference types, you need to use the find method. Let me show you. So I'm going to delete this line. Courses.find. Now look at the parameter of this method. What we see here is way too complicated. So whenever you want to learn about an object or a function in JavaScript, simply search for that. JavaScript array find. Here the first link is from developer.mozilla.org. So that's a good reference. Here you can find a good description of what this method does and a very simple example of using that method. So here we have an array with a few numbers. We're calling the find method. Note that as an argument to this method, we have to pass a function. We call this function a predicate, and we use that to determine if the given element exists in an array or not. So this function takes a parameter that's an element in this array. And in the body of this function, we should return a Boolean. So here we have a simple expression. If this element is greater than 10, we'll return true, otherwise we'll return false. So this is what happens when we call the find method and pass this function. This function is executed once for the first element in this array. So in this case, 5 will be passed here. 5 is not greater than 10, so we'll return false, and the search will continue. Now this function will be called for the second element in this array. So 12 will be passed as an argument to this function, and because it's greater than 10, we'll return true, and the search will stop here. So now, what we'll get here as a result of calling the find method is the first element that matches this criteria. So if we log this found variable on the console, we'll get 12. Now in contrast, if there are no elements in this array that matches this criteria, we'll get undefined. Let me show you. So back to our example, let's say we want to see if we have a course with the name A in this array. So we pass a function here. We call this a predicate or a callback function, because this function is called back as part of finding an element in this array. So here we should have a parameter. We can call that element or course. because each element in this array is a course object. So it's better to be more explicit. That makes our code more readable and understandable. So what is our criteria? We are looking for a course with the name equal to A. So we simply return this, and let's store the result in a constant called course. And finally, let's log this on the console. Here's the course object, save the changes, and that's the course with the name A. We get the complete course object that we have in this array. Now, if I change the search criteria to something like this, X, Y, Z, obviously we don't have a course with this name, so when we save the changes, we get undefined. So here's our find method. It returns the first element that matches this criteria. We have a similar method called find index. It works exactly the same, but instead of returning the actual object, like the course object, it will return its index. Let me show you. So I'm going to change this to find index. In this case, we don't have a course with this name. So when I save the changes, we should see -1 on the console. Here it is. Now, if I change this back to A and save the changes, we get 0 because the index of the first element that matched this criteria is 0. In the last lecture, you learned about this predicate function that we pass to the find method. In ES6, there is a shorter and cleaner way to write the same code using arrow functions. So whenever you want to pass a function as a callback function or as an argument to a different method, you can use the arrow function syntax. Let's see how that works. So you remove the function keyword, and to separate the parameters of this function from its body, put a fat arrow in between them. This is what we call an arrow function. Now, if your function has a single parameter, we can also get rid of the parentheses. And this makes your code cleaner. You're removing the noise in the code. If you don't have any parameters, you have to pass an empty parenthesis. In this case, we have a single parameter, so I'm going to bring that back. And finally, if your function is a single line of code and is returning a value, you can make this code even shorter. First, you get rid of the return keyword, and then you remove the curly braces, like this. And finally, you can put everything on one line. So here's the end result. We read this expression as course goes to course.name equals A. So basically, we are finding a course with the name equal to A. All right, now let's see how we can remove elements from an array. So start by declaring a new array, numbers, and we set this to 1, 2, 3, 4. Earlier in this section, you learned about 3 methods to add new elements to an array. You learned about the push method, which we use to add something at the end of an array. You learned about the onShift method that we use for adding elements at the beginning of an array, and the splice method that we use for adding an element somewhere in the middle. Now, when it comes to removing an element, again, we can remove an element from the end, from the beginning, and from the middle. But instead of the push method, we use the pop method. This will remove the last element in this array and return it. So let's store that in a constant called last. And here I'm going to do a console.log of numbers, so you can see the array after we pop the last element. And also I'm going to show you this last element. Save the changes. So here's our array, 1, 2, 3, and you can see the last element is 4. Now, if you want to remove an element from the beginning, you use the shift method. Similar to the pop method, this will return the element that was removed. So we can store that in first, and let's have a look here. Save the changes. So the first element is 1. Now, if we log numbers, we only have 2 and 3. Pretty easy. And finally, the splice method, you learned about that earlier. So if you want to remove an element somewhere in the middle, you pass the index of that element. So let's say we want to remove this 3 here. The index of this element is 2. So we pass 2 here. And as the second argument, we pass the number of elements we want to delete. We can remove one element, and then let's log this on the console, numbers, save the changes. Actually, the result is confusing. So I'm going to comment out these 2 lines so we work with our original array. Let's have a look. So note that 3 is removed. We have 1, 2, and 4. Now, if you want to delete multiple elements, you pass a value greater than 1. So we can delete 2 elements starting from index 2. Save the changes. So 3 and 4 are removed and we only have 1 and 2. So to recap, use the pop method to remove the last element, the shift method to remove the first element, and the splice method to remove an element somewhere in the middle of an array. So now you know how to remove an element from an array. But what about emptying an array? How can we remove all the elements in this array? Well, there are a few different solutions. Here's the first solution. We can simply reassign this to a new array. Now in this case, because we have declared this array using const, we cannot do this, so we have to change this to let. Now let's log numbers on the console. Save the changes. So now our array is empty. However, note that this old array is still in the memory. So if there are no other references to this object, eventually it will be removed by the garbage collector. So this means if we have, let's say, another variable called another, and this is also pointing to the same object, this original array will not be garbage collected. So on line 6, when we reassign the numbers variable, now numbers is pointing to a new object in memory, but another is still pointing to the old object. Let me show you. So here, instead of logging numbers, let's log another. Save the changes. So we can see another is still pointing to this array, to the original array. But if you look at the numbers, numbers is now pointing to a new object, to a new empty array. So this solution works if you do not have any other references to the original array. If you do have multiple references to the original array, then you need to use one of the other solutions. So I'm going to comment this out. Let's look at solution 2. We can simply set the length property to 0, and this will truncate the array. It will remove all elements. So here we're logging another. Let's also log the original array. Save the changes. You can see the original array is truncated, so it doesn't matter how many references you have to that array. So here's solution 2. The other solution is to use the splice method. So in the last lecture, you learned that with the splice method, you can go to a given position and remove one or more elements. So we can start from the first element and remove all elements in this array. How many elements do we have in this array? Well, that is numbers dot length. Okay, save the changes. Again, both arrays are emptied. And finally, the last solution is to use the pop method. So solution 4. So you learn that the pop method removes the last element in this array. Now we can put this in a loop and keep calling this method as long as we have an element in this array. So while numbers.length is greater than 0, we can keep popping elements. Save the changes. Again, both arrays are empty. Now, this last solution is not something that I recommend you to do, because if you're dealing with a large array, let's say if you have 1,000,000 objects in this array, there's going to be a performance cost. You're essentially calling this pop method 1,000,000 times, okay? However, that's not the situation with most applications out there, unless you work for Google. But in terms of clean coding, you can see this approach is pretty noisy. Compare that to the first solution. This is very simple, elegant, but the only issue it has is it doesn't work if you have multiple references to this array. So my personal preference is to set the length of the array to 0, but the first solution is also perfectly valid if you have a single reference to your array. And finally, similar to the last solution, you can see solution 3 is also a little bit noisy. So overall, I would go for either solution 2 or solution 1. All right, now let's see how we can combine two arrays or slice an array into two parts. So let's start by declaring two arrays. Here's the first one. We put 1, 2, and 3 here. And here's the second one. I'm going to add 4, 5, and 6. To combine these two arrays, we use the concat method. So first, dot concat. This will basically concatenate the first array with the second. Now, both arrays are unaffected, so this will return a new array, which is the combination of the first and second arrays. So let's store the result in combined and log it on the console, combined. Save the changes. So we get 1, 2, 3, 4, 5, 6. Pretty easy. Now we have another method that is the opposite of concat, that is slice. And we use that to slice an array into two parts. So let's get the combined array and slice it. Now there are multiple ways to use this method. One way is to pass a zero-based index for the start and end. So we can start at 2 and finish at 4. Let's see what we get. So let's call that slice and log it on the console. So this is what we get. We went to the combined array, started after index 2, so here, and finished after index 4. So we extracted 3 and 4. Now let me show you another way to use the slice method. We can exclude the end index, and with this, we get all the elements in the original array starting from the given index. So that's the second way. And finally, the third way is to exclude the starting index. And with this, we get a copy of the original array. So to recap, if you want to combine two arrays, use the concat method. If you want to slice an array, use the slice method. Now, one thing you need to understand about both these methods is that if you're dealing with primitive values, these primitives will be copied into the target array. But if you have objects in your array, the objects themselves are not copied, the references are copied. And that means the elements in both the input and output arrays will point to the same object. Let me show you what I mean. So for simplicity, I'm going to remove these three numbers here and add an object. So an object with ID set to 1. So now we have a reference type, right? When we call the concat method, this object itself is not copied to the combined array. Only its reference is copied. And this means if I go to the first array, get the first element, which is our object, and change its ID to, let's say, 10. Now, when we save the changes, you can see in the combined array, here's the first element, that's our object. Note that its ID is changed to 10 as well. So because we're dealing with a reference type, this object is copied by its reference. The same principle applies to the slice method. So as part of slicing this array, if the elements are primitive, they're copied by value. If they're reference types, they're copied by their reference. So in the last lecture, you learned how to use the concat method to combine two arrays. Now, there is another way to achieve the same thing using the spread operator in ES6. So I'm going to rewrite this code using the spread operator, and you will see why this approach is cleaner and more flexible. So I'm going to define combined as a new array. Now we want to combine all the elements of the first array and the second array. So we use the spread operator like this. First and then second. When we spread an array, all its elements are returned individually. So basically here we're declaring a new array, and in that array we're adding the individual elements of the first and second arrays. So this piece of code here is exactly like this. Okay, so you can see with the spread operator, we have a better visualization of how these arrays are combined. It's very clear that we have an array, and in this array, we have all the elements of the first array followed by all the elements of the second array. Now, with this spread operator, we have more flexibility. Let's say as part of combining these two arrays, we want to add an element in between them. We can do that easily like this. Or we can add something at the end. Again, we can clearly see what the combined array looks like. In contrast, if we want to do the same thing using the concat method, our code is going to be more complex. So this is how we can use the spread operator to combine two arrays. Now, in the last lecture, you learned that if you call the slice method without any arguments, this will return a copy of the original array here. So let's call that copy. Now, once again, we can use the spread operator to copy all the elements of an array into a new array. So we can rewrite this code like this. Constant, copy, we create a new array, and then spread the combined array. So this will return all the elements of the combined array and put them into this new array. So earlier in the section about control flow, you learned about various loops in JavaScript. So in that section, you learned that if you want to iterate an array, you can use the for of loop. So for let number of numbers. Now in each iteration, this number will be set to one of the elements in this array. So let's log that on the console. We get 1, 2, and 3. There is also another way to iterate an array, and you may see that approach in some tutorials online. That is using the for each method. So all these arrays have this for each method that takes a callback function. So we pass a function here. This function takes a parameter, in this case, number. And in this function, we can simply log this number on the console. So when we call the for each method, this function will be executed for each element in the array. Each element will be passed as an argument to this function. So save the changes. Again, we get 1, 2, 3. Now, as I told you before, we can use the arrow function syntax to simplify this code. So we get rid of the function keyword, put a fat arrow between the parameters and the body of the function. And because we have a single parameter, we can remove the parentheses. And finally, we need to remove this semicolon here because we don't have this statement in a code block. So here's the end result. Now, which approach you choose is more of a personal preference. There is really no significant difference between these two ways of iterating an array. The only thing you need to know is that this callback function that we pass to the for each method can optionally take a second parameter, and that's the index. So here, I'm going to put number in parentheses to add the second parameter, that's index. Now, when logging each number or each element, we can also display its index. Save the changes, and you can see the index of each element in front of it. We don't get the index with the for of loop, but if you need that, you can use the for in loop. Again, it's really a tiny issue. Just be aware that we have different ways to iterate an array. Another useful method of arrays is join. So here we have this numbers array. Let's say we want to join the elements in this array. That's when we use the join method. So we call numbers.join. Now look at this parameter here, separator. Note the question mark. Whenever you see a question mark, that means this parameter is optional. And you can see the type of this parameter is a string. So here we can optionally pass a string, and this string will be used as a separator. So let's say we want to join these elements using a comma. So we pass comma as a string here, right? And note that this join method returns a string. So we get the result and store it in a constant called joined. Now let's log it on the console. Joined. Save the changes. So here's the result. Another useful method that goes hand in hand with join is the split method. But this method is not part of arrays, it's part of strings. But let me show you how it works. So let's say we have a string called message like this. This is my first message. Now we can split the sentence like this. So message dot split. Again, here we need to pass a separator string. So let's say we want to separate this using a white space. Now this method will return an array. So let's call that parts. Now let's take a look at this array on the console. Okay, so here's the array. We have 5 elements here. Note that each element in this array is a word in our original message. Now that we have an array, we can use the join method to combine these elements using a separator. So let's say parts.join. We can combine them using a hyphen and store the result in combined and finally log it on the console. So here's the result. This is my first message. This technique is particularly useful when building a URL slug. Let me show you what I mean by that. So here I've got this page open on stackoverflow.com. Read the title of this question, Creating Arrays in JavaScript. So this is what the user posted. As you can see, we have a white space between each word, but we cannot have a white space in URLs. So if you look at this URL here, note the title of question converted to a URL slug. So all the white spaces are replaced with a hyphen. So as part of converting the title of the question to a URL slug, you'll have to split this string, perhaps throw out some of the words, maybe replace some words with other words, and then eventually combine them using a hyphen, as you can see here. Back to our numbers array. In this lecture, I'm going to change the order of these numbers so they are not sorted, and then I will show you how to sort them. So let's change them to 2, 3, 1 and remove 1 here. Now, how can we sort this array? Very easy. We have this method called sort, and what this method does is that it converts each element here to a string and then sorts the elements in the array. So let's have a look. Console.log of numbers. Here's our numbers array sorted. Now, another method that is often companion to the sort method is the reverse method. And with this, we can reverse the order of elements in an array. So numbers dot reverse. Let's log it on the console one more time. Now we have 3, 2, 1. So this sort method is pretty useful, is very easy to use when you have numbers and strings in an array. But when you have objects like course objects, it doesn't work by default. We have to do some extra work. So let me delete this code here and define another array called courses. Here I'm going to add 2 course objects with ID 1 and name, let's say node.js, and another course object with ID 2 and name JavaScript. Now, let's say we want to sort this array by the name of courses. So JavaScript should come before Node.js. So look, if I call courses.sort and then log in on the console, nothing is going to happen. You can see Node is still coming first. So how can we fix this problem? Very easy. This sort method optionally takes an argument, and that's a function that is used for comparison. So when we call the sort method, this method gets 2 objects in this array, let's say A and B, and compares them. Now, if they are in the right order, it will skip to the next 2 elements. Otherwise, it's going to rearrange them. So here we need to pass a function for comparison. This function should take 2 parameters. We can call them A and B, or first and second. It doesn't really matter because A and B is pretty self-explanatory here. Now, in this function, if A is less than B, we should return -1. If A is greater than B, we should return 1. And if they are equal, we should return 0. So to implement this, we can write code like this. If a.name, that's our first course, is less than b.name, we're going to return -1. Okay. Now the second condition, if a.name is greater than b.name, we're going to return 1. Otherwise, we return 0. Now note that here I'm not using else if, because if the first condition is true, with this return statement, we're going to jump out of this function. So the control will never move to this point. So there's really no need to use the else keyword. It's just adding extra noise in the code. So now let's run this code one more time. Save the changes, inspect this array. You can see that JavaScript is coming first. Beautiful. However, if I change this j to a lowercase j and save the changes, see what happens. This time node is coming first. So what's going on here? Well, each character in a computer is internally represented using a number. Let me show you. So open up Google and search for ASCII table. That is ASC with double I. I remember when I was at university back in Iran, I had this lecturer and he thought these double I's here are 2. So he used to call this ASCII 2. He had no clue that these I's stand for information interchange. So ASCII is short for American Standard Code for Information Interchange. So that's ASCII table, not ASCII 2. Now, take a look at this second link. So on this table, you can see the numeric representation of each character. So we were looking at lowercase j. Its numeric representation is 106. And n, which is used for our node course, is 78. We can see 78 is less than 106. That's why our node course, starting with capital N, came first. Now, to solve this problem, we should exclude case sensitivity when comparing these names. So we can do something like this. We can declare 2 constants. Let's say name A and set it to a.name dot to uppercase. So whatever the name of the first course is, we're going to convert it to uppercase. And we're going to do the same with the second course. So I'm going to call the second constant name B and set it to b.name to uppercase. Now we have 2 uppercase strings. We can compare them. Also take into account that here we could call 2 lowercase instead of 2 uppercase. That's perfectly valid. But what is important is that both these names should be either lowercase or uppercase. Now finally, we need to replace the instances of a.name with name A. So I'm going to do multi-cursor editing. I've selected a.name and I'm going to press Command and D on Mac or Control D on Windows. We have this second cursor here, as you can see. Now we can delete this and replace it with name A. Escape. Finished. One more time, I'm going to replace b.name, Command and D, with name B and escape. Done. Save the changes. Now our sort algorithm should work properly. So JavaScript came first. We have 2 new methods in modern JavaScript called every and some. Very useful methods. So here we have our numbers array. Let's imagine we want to check and see if all numbers in this array are positive. So we call numbers.every, and here we pass a callback function. Here in the IntelliSense, you can see this callback function has 3 parameters. Value, which is a number because here we have an array of numbers. Index, which is the index of this value in the array. And again, that's a number. And finally, the array itself. Now, when writing this function, you don't have to add all these parameters. You can only add the ones that you need. For example, here I'm going to add a function. And I'm only going to add 1 parameter value because I don't care about the index of these elements. So we pass this callback function. And in this function, we can check to see if this value is a positive number. So we return value greater than or equal to 0. If this expression value is to true, we'll return true, otherwise we'll return false. Now finally, this method will return a boolean, so we can store it in a constant called all positive. So when we call this method, this is what's going to happen. This method will run this function on every element in this array. As soon as it finds an element that doesn't match this criteria, it's going to stop searching. Let me show you. So let's log all positive on the console. You can see it's true because every element or every number in this array is a positive number. However, if I add -1 here, we get false, and basically as soon as we hit this number, the search will terminate. So if we have a million other numbers in this array, this every method is not going to call this callback function on those numbers. Okay. Now we have a similar method called sum, and that checks to see if we have at least one element in this array that matches this criteria. So if I replace every with sum and save the changes, we're going to see true. However, I'm going to change the name of this variable because this is distracting. So always pay great attention to the name of your variables and functions. Make sure they're explaining the right thing. So press F2 and rename this to at least one positive. Okay, save the changes, we get true. So this sum method will run this callback function on every element in this array. As soon as it finds an element that matches this criteria, it's going to return true and the search will terminate. So in the current example, if we have a million numbers in this array, because the first number matches this criteria, this callback function will be executed only on this first element. So it doesn't matter what we have after the first element. So to recap, every checks to see if every element in a given array matches the given criteria, and sum checks to see if we have at least one element that matches the given criteria. Just to let you know, these methods are new in JavaScript, so some older browsers do not support this. But later in the course, I'm going to explain how to bring these methods in older browsers. In this lecture, I'm going to show you how to filter an array based on a search criteria. So back to our numbers array, let's say we want to return only the positive numbers. So we can use the filter method like this. Filter. Once again, we need to pass a callback function. This function has 3 parameters: value, index, and array. So out of these, we only care about value. We don't care about the index because I just want to see if the number or the value is positive. So function value. Now here we can write a simple expression like this: if value is greater than or equal to 0. So when we call the filter method, this method will loop through this array and execute this callback function for each number, for each element. Now, if the element matches this criteria, it will add this element to a new array. And finally, we can get that new array here. So filtered. Let's take a look at the result. Filtered. So in our filtered array, we have only 1, 2, and 3. Now, earlier you learned about arrow functions. So this is a good case where you would use an arrow function. We have a single line of code in this function, and we're simply returning a value. So we get rid of the function keyword, put a fat arrow between the parameter and the body of this function. We don't need the parentheses because we have a single parameter. And because we're simply returning a value, we can also exclude the return keyword as well as the curly braces, and then put everything on the same line like this. Now we can make this code a little bit shorter. So in this case, we can use an abbreviation like V for value or N for number, because it's obvious that we're working with the numbers array. So we filter and we get numbers where number is greater than or equal to 0. Now here we're dealing with an array of numbers. In a real-world application, you would be using an array of objects. For example, here on the Yelp website, we can click this button to find only the restaurants that are open now. So this is one kind of filtering. So if you want to implement something like this, instead of an array of numbers, you would have an array of restaurants, and each restaurant has opening hours. So you could filter restaurants that are currently open and return them. Another very useful and powerful method we have in modern JavaScript is the map method. With this method, we can map each item in an array to something else. So following from the example in the last lecture, we have an array of positive numbers. Let's say we want to construct some HTML markup using the elements in this array. So we call filtered.map. And once again, we need to pass a callback function here. This function, just like the function that we passed to the filter method, can have three parameters: value, index, and array. So in this case, again, we're going to work only with the value. So we can pass a function or an arrow function. So we get a number, and then we want to map this to some HTML markup. So we can add a string in an opening list item element. Then we add the number, and finally the closing list item element. So with this markup, we can display each number using a bullet point. Of course, we need to put these inside of a UL element, and I'm going to show you that in a second. So let's see the result of the map method. I'm going to store the result in a constant called items. And now let's display this on the console. So you can see each number is now mapped to a string. That's our list item. So now we have an array of strings. We can use the join method that you learned about earlier to join the elements of this array and create a string. So constant HTML, we set it to items.join, and then display this on the console. Now, instead of an array, we have a string. Note that by default, comma is used as the separator. We don't want to have comma in our HTML markup. We just want to combine these using an empty character like this. Save the changes. Now comma is gone. The only bit that is remaining is the UL element. So a very simple implementation would be like this. We add UL, then concatenate it with all these items, and finally another UL. Save the changes, and here's our HTML markup to display all these numbers using bullet points. Now later in the course, I will show you a more elegant way to implement the same thing. All I want you to take away from this lecture is that we can use the map method to map each element in an array into something else. Now in this example, we are mapping these numbers to strings, but you can also map them to objects. Let me show you another example. So I'm going to delete this HTML. Let's expand this a little bit more. So instead of mapping a number to a string, let's say we want to map them to an object. So here I'm going to define an object. In this object, we want to have a value property, and we want to set that to this number. And finally, we want to return this object. Let's look at the result. Oops, I made a mistake. I deleted the HTML constant, and that's why we get this error. HTML is not defined. So let's display the items constant. Now here's the result of our map. We mapped each number to an object with a value property. Okay, it's very useful when building real-world applications. Now let me show you something tricky here. In our callback function, we are declaring this constant and then returning it. Technically, we don't need to declare this as a separate constant. We can simply put the return keyword here and return this object, because we're not working with that constant, with that object constant, okay? So save the changes, we still get the same result. Now, earlier I told you that in your arrow function, if you have a single line of code and you're returning a value, you can exclude the return keyword as well as the curly braces. So let's do that and see what happens. So remove the return keyword and the curly braces, then put everything on one line like this. Now, if we save the changes, we don't get the same result. We get an array of 3 undefined elements. The reason for this is that by default, these curly braces in an arrow function represent a code block. So when the JavaScript engine tries to parse this arrow function, it thinks here we're defining a code block as opposed to an object to return. So if you're returning an object, you need to put that object in parentheses, like this. So we put this object in parentheses. And with this, our JavaScript engine will not look at this as a code block. Now save the changes. Now, once again, we get 3 objects. And one last thing before we finish this lecture. So you have noticed that both the filter and the map method return a new array. They don't modify the original array, okay? Now, these methods are chainable, which means we can call them one after another in a chain. So in this case, this filtered constant is only used here. We haven't used this anywhere else in the code. So we don't have to explicitly store the result of this statement inside a separate constant. We can get rid of this. We call the filter method. Now, we don't want to have a semicolon here because we are not going to terminate this statement. Instead, we're going to immediately call the map method on the result that is returned from this statement, okay? So I'm going to copy our map method here. This is what we call chaining. So we're calling one method. That method returns some result. Now we're immediately calling the map method on that result. Now, when chaining multiple methods, by convention, we put each method call on a separate line, and this makes our code cleaner. Have a look. So numbers.filter, and then .map, and so on. And finally, we store the result in the items. That's a better and cleaner code. Save the changes, we still get the same result, right? Now note that here, because the map method is returning a new array, again, we can call the filter or the map method on that array. So here we can call the filter one more time. We get an object, and maybe we want to get objects with value greater than 1. See what happens? Now in the result, we have only 2 objects in our array, objects with value 2 and 3. And again, we can call the map method and maybe map each object to a number. So we read the value property and return it. Save the changes. Now we have an array of 2 numbers. So this is the power of chaining these methods. Once again, with our array of numbers, let's say we want to calculate the sum of all these numbers in this array. This would be similar to calculating the total cost of all the items in a shopping cart. So each numbers here could represent the price of an item in a shopping cart. Of course, we wouldn't have a negative number there, but you got the point. So here's a very simple algorithm for calculating the sum of all the numbers in this array. We start by declaring a variable called sum, and we initialize it to 0. Next, we loop over this array, get each element or each number and add it to sum. Something like this. For let n of numbers. Now we want to add n to sum. So we can write an expression like this. Sum equals sum plus n. Or a better way is to use the addition assignment operator. So we can exclude this second sum. So this is exactly like the statement we had before. And finally, we display sum on the console. So we get 5. Now there is a cleaner and more elegant way to write the same code using the reduce method in arrays. So all these arrays have this reduce method. And with this method, we can reduce all these elements in an array into a single value. That single value can be a number, it can be a string, it can be an object, it can be anything. In this example, we want to reduce all these elements into a single number. That is the sum of all the numbers in this array. So let's see how we can use the reduce method. This method takes a callback function with two parameters, accumulator and current value. So here I'm using an arrow function like this. This accumulator parameter here is exactly like this sum we have here. It's something that we initialize, and then this callback function is executed multiple times. Each time, this current value will be set to one element in this array. Okay? So in each call, we want to get this current value and add it to accumulator. So we simply return the sum of accumulator plus current value. Now, internally, this reduce method will get this result and store it in the accumulator. You will see that in a second. Now, one last thing we need to do here is to initialize this accumulator to 0. So as the second argument to the reduce method, we pass 0. Note that this reduce method has two arguments. The first argument is a callback function, and the second argument is the initial value for the accumulator. Finally, we get the result as a single value, in this case, sum. Now we don't need this code anymore. And finally, let's bring this console.log here. Save the changes. You can see we get the same result, 5. But let's see what exactly is happening here. So initially we said accumulator to 0. So I'm going to set a equals 0. In the first round, current value will be set to the first number. So c equals 1. Now we add this together. So we get 1, and a will be set to 1 after this callback function is executed. So as a result, a will be 1. Now in the second round, a is 1. Current value will be set to the second number in this array. So minus 1. Now once again, we add them together. So a will be 0 after the second call. Now the third call. So a is 0. The current value is going to be set to the third element in this array. So 2. And as a result, a will be 2. And finally, in the last call, we start with a set to 2. And current value will be 3. Okay? So the result will be 5. And that's why we saw 5 on the console. So essentially, with this reduce method, we start with an accumulator. Then we loop through this array and convert all these elements into a single value, which is in this case, accumulator, or the sum of all the numbers in this array. Now we can make this code even shorter. We can exclude the initialization of the accumulator, and with this, accumulator will be set to the first element. So let me show you what will happen. A will initially be set to 1, and current value will be set to minus 1. That is exactly like our second call here, right? So as a result, a will be set to 0. Now, in our second round, a will be 0, and current value will be 2. Because in the previous call, current value was here, so now we are here. So current value will be 2, and as a result, a will be 2. And finally, in the last call, a will be 2, and current value will be 3, the last element in this array. And once again, we get 5. So if we supply an initial value, we'll have one more call. If we don't, the first element in this array will be used as the initial value. So this is how the reduce method works. And finally, to make this code a little bit shorter, we can get rid of this return keyword because we have a single line and we are simply returning a value. So remove the return, the semicolon, and the curly braces. Put everything on a single line like this. So with this single line of code, we reduce the numbers array, and this is how our reduction algorithm works. We simply get the current value and add it to our accumulator. This is far cleaner and more elegant than declaring a sum and then looping over this array, like let n of numbers and then add n to the sum. That's a very old way of writing code. All right, so we have covered a lot about arrays. Now it's time for some exercises. Here's our first exercise. I want you to write a function called array from range. This function should take two parameters, min and max, and this is how we can use this function. So when we run this program, we get an array, and in this array we have numbers from 1 to 4, as you can see here. We can also pass a negative number here, let's say from -10 to -4. So we'll get an array like this. So pause the video, spend 5 minutes on this exercise, and when you're done, come back, continue watching. All right, so I'm going to define a function called array from range with min and max parameters. Here, first we should create an empty array. So let's call that output and set it to an empty array. Now we need a for loop to generate numbers between min and max. So for let I equal min. As long as I is less than or equal to max, we're going to increment I and then push this I into our array. So output.push I. And finally, we return this output. Now let's test this. So save the changes. With -10 and -4, these are the numbers we get. If we pass a positive number, like 1 to 4, here's the output. If the maximum value that we supply is less than the minimum, we get an empty array. All right, now our second exercise. So here we have an array of numbers. You have seen the includes method before. So console.log numbers.includes. With this method, we can check to see if a given element exists in the array. Now, your exercise is to write a function like the includes method. So imagine we don't have this method in arrays. Your job is to implement this method yourself. So I want you to create a function called includes that takes an array and a search element. If we have the search element in the array, we should return true. Otherwise, we should return false. So pause the video, do the exercise, and when you're done, come back, continue watching. All right, so here we need to iterate over this array. If we find an element that equals the search element, we're going to return true. Otherwise, we're going to return false. Very, very easy. So for, we're going to use the for of loop. So for let element of array. Now, if element equals this search element, we're going to return true. So we don't need to search the rest of this array. We immediately return true. Otherwise, if we get to this point, that means we didn't find this element in the array, so we return false. Now let's test this. So I'm going to call the includes function, pass our numbers array as the first argument and 1 as the second argument. Obviously, we have this number, so we get true. But if we pass -1, we get false. All right, here's the third exercise. So we have this numbers array and a function called except that takes an array and another array. And in this array, we can add the values we want to be excluded from the original array. So this function returns a new array without the values that we have passed here. So if you run this program, we get a new array with these 3 values, 2, 3, 4, because we excluded 1. Note that it doesn't matter how many ones we have here, so I can add a couple more ones and we still get the same result. Or we can add multiple values here. So let's say we want to exclude 1 and 2. So as a result, we'll get 3 and 4. So get started. You will see my solution next. All right, here we need to declare an array called output and initialize it to an empty array. This is what we're going to return from this function. Now we need to iterate over this original array. And for each element, we have to see if that element is in this other array. If it's not, then we will add that element into this new array. Okay, so for let element of array, we iterate over the original array. Now we should see if this excluded array includes this element. So basically we're checking to see if the current element is in the excluded array. If it's not, so we apply the not operator, then we will add this element into our output array. So output.push element. And finally we'll return output. So save the changes. If we exclude 1 and 2 here, we'll get 3 and 4. If we exclude all numbers 3 and 4, we'll get an empty array. Alright, this exercise is a little bit tricky, but trust me, it's absolutely worth spending time on it because it trains your programming brain. So we have this function called move, and we use that to move an element in an array. So this is how it works. We give it an array, the index of the element we want to move, and an offset. So in this case, I want to move the first element in this array, that is 1. Now I have passed 0 as the offset. So with this, nothing is going to change. We're going to get the same array. However, if I pass 1 as the offset, see what happens here. So 1 moves 1 position to the right. If I pass 2 as the offset, 1 ends up here. If I pass 3, it ends up being at the end of the array. If I pass anything more than the length of the array, that is 4, I get this error, invalid offset. Now to display errors like this, you should use another method called console.error. So you simply pass a string and that will end up appearing as a red message on the console. Now also note that this offset can be a negative number. So let's say we want to move this second element 1 position to the left. So we set index to 1 and offset to -1. So 2 moves to the beginning of the array. If I pass -2 as the offset, because it can't jump out of the array, once again, we're going to get this error, invalid offset. Also note that in all these examples, the original array is unaffected. So we get a new array with items reordered. So spend 10 to 15 minutes on this exercise. And when you're done, come back, continue watching. All right, so I've reset these numbers to 0 and 1. So we want to move the first element in this array 1 position to the right. The first thing we want to do is to copy this array because we don't want to modify it. So that's where we use the spread operator. I'm going to define a constant called output, set it to a new array, and then I'm going to spread the original array. So this will be a clone of the original array, okay? Now, as part of moving an element, first, we need to remove it from the array, and then we need to place it back at the right position. To remove an element from an array, we use the splice method. You have seen that before, splice. So we go to the given index and delete 1 item. Now look at the return value of this method. It returns an array. So the items that are removed will be returned as an array. In this case, we're removing 1 item, so we can access the first element in that array, and that will return the element that we just deleted. So let's store that in a separate constant. The reason I'm storing it here is because next we need to add this back to the array. Now we want to add this at a specific position. Once again, we need to use the splice method. So output.splice. Now where are we going to place this? We want to go to index plus offset. Now we don't want to delete any items here, so we pass 0. And finally, we pass this element that we want to place in the array. And finally, we return the output. Let's test this. So if we move the first element 1 position to the right, we get the right result, beautiful. If we move it 2 positions to the right, it ends up here. If we pass 3, it ends up being at the end of the array. If we pass 4, we don't get the error that I told you should produce, but the output is still the same. Now to solve this issue, we need to come back here and do some basic validation. before running this algorithm for moving an item. So we can do something like this. We define a constant, call it position. That is the new position, right? And that's going to be index plus offset. Exactly the same value we have used here. So we can replace this expression with position. Now we have position. We can check to see if position is greater than or equal to array.length. So in this case, our array has 4 elements. If it has 4 or a greater value, we should see the error on the console. So here we add the code block, console.error, invalid offset. And finally, we return, so the rest of this function is not executed. The other option would be to have an else block here, but that means we have to put this code inside this block. There's going to be a bit of indentation. This is really unnecessary because if we return here, none of the code here will be executed. So we can get rid of the else keyword as well as the code block and extra indentation. So if we pass 4, we should get the error. Beautiful. Now let's pass 0. So we're not going to move this element. We get the original array. Beautiful. If we pass -1, we get some weird result. In this case, 1 should not jump out of the array. So we need to change our validation logic here to something like this. So if position is greater than or equal to the length of the array, or position is a negative number, then we should display the error. So save the changes. Beautiful. Now let's test this with another value. So I'm going to work on the second element here. So let's change 0 to 1. We're going to move this 1 position to the left, save the changes. 2 comes here. Beautiful. If we pass -2, again, we should get the error. Here is the error. Perfect. Now let's change this back to 0. So we get the original array. If we pass 1, 2 moves here. If we pass 2, 2 moves to the end of the array. If we pass 3, we should get an error. And here's the error. Beautiful. All right, now I want you to create a function called count occurrences. This function takes an array and a search element and returns the number of times that search element has occurred in this array. For example, here in our numbers array, we have a single instance of 1. So if we call this function and pass 1, we get 1. If I add another 1 here, now you can see we have 2 instances of 1. Or if we call this function with a number that does not exist in the array, we get 0. So start with the simplest implementation for this function. Once you get that working, then to challenge yourself, implement this function using the reduce method in arrays. Because here essentially we are reducing this entire array into a number. And that number represents the number of times a given element has occurred in our array. You will see my solution next. All right, here's the basic implementation. So we declare a count variable and initialize it to 0. Now we need to iterate over this array. And if you find this search element, we're going to increment count. At the end of this function, we'll return count. Very easy. So for let element of array. Now, if this element equals the search element, we simply increment count. And finally, we return count. So that's the most basic implementation. Now let's see how we can use the reduce method to achieve the same thing with less code. So instead of this implementation, we're going to use array.reduce. Here we need to pass a callback function with 2 parameters, accumulator and current. And this goes to this code block. So this accumulator represents the number of times this search element has occurred in our array. So I'm going to initialize this to 0, like this. Now, every time this callback function is called, we want to compare this current value with search element. If they are equal, we should return accumulator plus 1. Otherwise, we should return accumulator. So we can do something like this. We define a constant, called occurrence. Now, if current equals search element, here I'm going to use the conditional operator. So if they're equal, I'm going to add 1 to accumulator. Otherwise, I'm going to add 0 to accumulator. And finally, we're going to return accumulator plus occurrence. Now, let me show you how this works. So let's do a console.log. We're going to log 3 values. One is our accumulator, and the other 2 are current as well as the search element. And one last thing we need to do here is to actually return this value. So let's inspect this program. We save the changes. Here in the console, you can see this callback function has been called 5 times. 1, 2, 3, 4, 5. And here's the result, because we don't have -1 in this array. Now let me change this to a value that we have so you can see exactly what is happening under the hood. So I'm going to change -1 to 1, save the changes. Now let's see what's happening. So in the first round, our accumulator is 0, current is 1, so is search element, so accumulator is incremented by 1. So in the second round, accumulator is 1, current is 2, and our search element, as we can see, is always 1. Now in this case, these two numbers are not equal, so accumulator is not changed. So we simply return accumulator plus 0. We want to make sure to keep this number as we go through this array. Now finally, in the last call, you can see accumulator is still 1, and in this case, the current value and the search element are equal, so accumulator is incremented by 1, and that's what we get out of this reduce method. All right, here's another exercise. In this exercise, I want you to create this function, getMax. We give it an array, and it returns the largest number in that array. So if we give it this array of numbers, it returns 4. If we give it an empty array, it returns undefined because we don't have anything in this array. So we cannot return 0 or a negative number because none of these values exist in this array. So go ahead, do this exercise. Start with a simple implementation. Once that implementation is working, then to challenge yourself, implement this function using the reduce method in arrays. You will see my solution next. All right, so let's start with the simplest implementation. First, we want to check to see if this array is empty or not. If it's empty, we're going to return undefined. So if array.length equals 0, we're going to return undefined. Also note that by convention, sometimes if you have an if statement with only one line after, some developers prefer to put that line right next to the if statement. Some developers format it like this. It's more of a personal preference. There's really no right or wrong. So I'm going to put this on the same line. Now, otherwise, we have at least one element in this array. So I'm going to declare a variable, call it max, and set it to the first element in this array. So we want to assume that the first element is the largest number. Next, we will iterate this array. And if we find a number that is larger, then we're going to reset this max variable. So let's do a for loop. Let I, we start from the second element in this array and run this loop as long as I is less than the length of the array. Then we increment I. Now we need to check to see if the current number is larger than max. So if array of I is greater than max, then we're going to set max to this current value. Okay. Finally, after this loop, we want to return max. So that's the simplest implementation. If we run this code and pass an empty array here, we get undefined, beautiful. If we pass an array with only one number, we get that number. If we add 2 numbers here, 2 is the largest number. Let's add a few more values here. Now we should get 3, beautiful. So our basic implementation is working. Now let's re-implement this method using the reduce method. So we want to keep the first line as is. So if we don't have anything in this array, we want to return undefined. Otherwise, Let me comment out this code so you can compare them side by side. So we use array.reduce. We pass an arrow function with two parameters, accumulator and current. And that goes to this code block here. So you know that if we don't pass an initial value for the accumulator, by default, it will be set to the first element in the array. That is exactly like what we have on line 11. So in the body of this arrow function, we want to check to see if the current value is greater than what we have in accumulator, exactly like what we have here. If it is, then we want to return the current value. Otherwise, we want to return accumulator. So we can write code like this. If current is greater than accumulator, we want to return current. Otherwise, we'll return accumulator. Now we can rewrite this using the conditional operator. So let me expand this. So instead of these two lines, we can do something like this. Return, we add our condition, which is current greater than accumulator. If that's the case, we want to return current. Otherwise, we return accumulator. That is cleaner, right? Now we can make this code even cleaner by renaming these two parameters to something like A and B. So basically, we're reducing this array. We get two elements at a time. If B is greater than A, we're going to return B. Otherwise, we're going to return A. Actually, I personally prefer to change the order of these operands. So I would like to say if A is greater than B, then I want to return A. Otherwise, I want to return B. That is very easy to understand. Also, because we have a single line of code here, we're simply returning a value. We can get rid of the return keyword as well as the curly braces, bring everything on one line. And here's the end result. So basically, you can see this line of code is equivalent to all these lines here. That is the beauty of the reduce method. So this is what I want you to take away from this exercise. Anytime you have an array of values and you want to get a single value as a result of iterating that array, think of the reduce method. In this case, we're finding the largest value in this array. So we're reducing this array into a single value. All right, and finally, we need to return whatever we're getting from the reduce method. Now, let's test this and make sure everything is working. So I'm going to save the changes. We still get 3. If I pass an empty array, we get undefined. Beautiful. All right, this other exercise is a little bit different from the exercises we have done in this section. I want you to code along with me like this. So let's declare a constant called movies. We set this to an array of objects. In this array, we're going to have 4 movie objects. In each movie, we're going to have 3 properties. Title, set the first one to A. And then the second property is year. We set this to 2018. And the third property is rating, which we set to 4.5. Now let's duplicate this a few times. So hold down Shift, Alt, and the down arrow. With this, we can easily duplicate the current line. Now change the title of each movie. So the second one is going to be B, and then C, and then D. Let's change the year of the last movie to 2017. And finally change the ratings to 4.7, 3, and 4.5. Now with this array of movies, your exercise is to write code to get all the movies in 2018 with rating greater than 4. I want you to sort them by their rating in a descending order. So movies that have a higher rating should come first. Then I want you to only pick their title property and display it on the console. So the result should be B and A. That is what you should see on the console. So go ahead, spend 5 minutes on this exercise, and you'll see my solution next. All right, so we want to filter movies by their year and rating. So movies dot filter. Here we pass an arrow function. So m, as in short for movie, goes to m.year should equal 2018, and m.rating should be greater than or equal to 4. So that's the first part, our filtering. Next, we want to sort them by the rating. So as you learned earlier, these methods are chainable because filter returns a new array, so we can immediately apply the sort method on that array. Now, as you learned earlier, this sort method by default only works for numbers and strings. For objects, we need to supply a comparison function. So here, once again, I'm going to use an arrow function that takes A and B. So these are two movie objects in our movies array. So A and B goes to, now basically, if A is less than B, we want to return -1 or a negative value. If they are equal, we want to return 0. And if A is greater than B, we want to return +1 or a positive value. A simple way to implement this is like this. So I'm going to delete all this and the curly braces. We simply get the rating of A and subtract it from the rating of B. So let's say the rating of A is 4.5 and the rating of B is 4. When we subtract A from B, we'll get 0.5. That's a positive number. So that means A is greater than B. Now, if both these ratings are equal, we'll get 0. And that means A equals B. So we don't need 3 if statements here to return -1, +1, or 0. Okay? We simply subtract these values. Now, this sort method returns values sorted in an ascending order. But what we want here is descending order. So we need to call the reverse method to change the order of these movies. And finally, to pick only their title, we want to use the map method. So map, we get a movie object, we pass an arrow function. So m goes to m.title. That's the code you should have written. So let's store the result in a constant called titles, and finally display them on the console. So we get B and A. So you have learned a little bit about functions in JavaScript. In this section, we're going to examine functions in more detail. So I'm going to start by defining a function called walk. And here we do a console.log of walk. What we have here is what we refer to as a function declaration. But in JavaScript, there is another way to define a function, and that is using a function expression. So we start by declaring a variable or a constant, give it a name, like run, and then we set that to a function. So just like we can set a variable to a number or a string or an object, we can also set it to a function. And you know that in JavaScript, functions are objects. So setting the run variable to a function is similar to setting it to an object, okay? And at the end here, we need to add a semicolon, because whenever we declare a variable or a constant, we terminate this statement with a semicolon. So here's another example. We set x to 1 and terminate it with a semicolon. In contrast, we don't put the semicolon when we define a function using the function declaration syntax. It doesn't really matter. So if we run this code, we're not going to get any errors. But by convention, we don't do this. So that's one difference between function declarations and function expressions. Now, let's do a console.log of run here. So basically here we have defined a function, and this function does not have a name. Its syntax is very similar to what we have in a function declaration, except that here we don't have a name. We can give it a name, and then we would refer to this as a named function expression, or we can exclude the name. And with this, we'll have an anonymous function expression. So we have defined an anonymous function that doesn't have a name and set run to reference that function. So now we can call that anonymous function using this reference, just like how we call a function in JavaScript. So save the changes and we get the run message on the console. Now we can declare another variable, call it move, and set it to run. So now both move and run are referencing the same anonymous function, which is one object in memory. So we can call that anonymous function using this other reference. So if we call move, we get the same result. So to recap, in JavaScript, there are two ways to define a function. We can use the function declaration syntax or function expression, which basically involves declaring a variable or a constant and then setting it to a function. In the next lecture, we'll look at the key difference between a function declaration and a function expression. In the last lecture, you learned about function declaration and expression. Now, the key difference between these two functions is that we can call this function, the one that is defined using the function declaration syntax, before it is defined. So here we can call walk, save the changes, and we get this message on the console. But we cannot do this with a function that is defined using the function expression syntax. So here, if I call run before it is initialized, I get this error, uncaught reference error. Run is not defined. This is exactly like using a variable or a constant before it is defined. For example, here I'm going to define x and set it to 1, but I want to log it on the console before its declaration. Look, we get the same error. Reference error, x is not defined. So we can call a function that is defined using the function declaration syntax before its definition. But why is that? The reason for this is because when our JavaScript engine executes this code, it moves all the function declarations to the top. So our code will look like this at runtime. This is what we call hoisting. So if you are in a job interview and somebody asks you, what is hoisting in JavaScript? Hoisting is the process of moving function declarations to the top of the file. And this is done automatically by the JavaScript engine that is executing this code. So that's the reason we can call functions that are defined using the function declaration syntax before their definition. Earlier in the course, you learned that JavaScript is a dynamic language. So we can declare a variable, set it to a number, and then change its type and set it to a string. And that's perfectly fine from the perspective of a JavaScript engine. This is one of the characteristics of a dynamic language. But we have the same concept in the arguments of a function. So I'm going to define a function here, call it sum, that has two parameters, a and b. And here we simply return the sum of a and b. Now let's do a console.log and call the sum function, pass 1 and 2, save the changes, so we get 3. But in JavaScript, it doesn't matter that this function has two parameters. We can pass only one argument. So in this case, we get not a number, because here a is 1 and b by default is undefined. So when we have un plus undefined, the result is not a number. This is not a valid arithmetic operation. The same happens if we don't pass any arguments. So we don't get an error, we get not a number as a result. By the same token, we can pass additional arguments. So in this case, we can pass, let's say, 5 arguments. And that's perfectly valid JavaScript code. So when we save this, we still get 3 because only the first 2 arguments are used. But what if we want to have a varying number of parameters in a function? What if we want to have the flexibility to pass as many arguments as we want and get their sum? Well, every function in JavaScript has a special object called arguments. Let's log this on the console, console.log. So this is the arguments object. You can see that it kind of looks like an array, but it's not an array, it's an object. But the keys we have in this object are the indexes of the arguments passed to this function. So the first argument is 1, the second argument is 2, and so on. Here we have a length property that returns the number of arguments that are passed. We have this other property, callee, which returns the currently executing function. So you can see here we have a reference to our sum function. So this is the arguments object. Now, if you want to have a function with a varying number of parameters to work with all the arguments that are passed to this function. So let's say we want to change this function to return the sum of all its arguments. Here's a very simple algorithm. So we declare a variable called total, set it to 0. Then we can use the for of loop. So let value of arguments. We can use this loop to iterate over this arguments object. Now, earlier I told you that we can use the for of loop on arrays, but technically this loop can be used on any object that has an iterator. So the plain objects that we create with the object literal syntax, they don't have an iterator, but this particular object, you can see here we have symbol.iterator. That means this object has an iterator, so we can use the for of loop to iterate this object. Now, for every argument, we're gonna get that and add it to our total variable. And finally, we will return total. Now, save the changes. We get 15. We can add another argument and we get 25. Now, here's the interesting thing. We can completely remove these parameters here because technically here we are working with the arguments object to access the arguments that are passed here. We are not referencing A or B anywhere in the body of this function. So we can simplify this code and remove these parameters. In the next lecture, we're going to look at a better way to implement this function. In modern JavaScript, if you want to have a function with varying number of parameters, you can use the REST operator. Let me show you how that works. So here we modify the declaration of this function, add a parameter, let's call it args, and then prefix it with 3 dots. This is what we call the REST operator. Now don't confuse this with the spread operator because spread operator looks exactly the same. Earlier we used the spread operator with arrays. So with the spread operator, we can spread an array, which basically means taking its individual elements. But when we use this along with the parameter of a function, we refer to this as the REST operator. And you will know why this is called REST in a second. So let's see how the REST operator works. I'm going to delete all this code and simply do a console.log of args. So here we're calling this function with 6 arguments. Save the changes. Now here on the console, you can see args is an array of 6 elements. This is a real array. Note that if I remove these 3 dots, that basically means this function has a single parameter called args. So when I save the changes, instead of this array, you're going to see 1 because the first argument that we're passing to this function is 1. Save the changes, we get 1. So here's the lesson. When we apply the REST operator to a parameter of a function, we can pass varying number of arguments and the REST operator will take all of them and put them in an array. Now, if you want to get the sum of all the numbers in an array, we can use the reduce method. You learned about that in the section about arrays. So args is an array. We can call the reduce method and pass an arrow function here. A and B goes to A plus B. You've done this before, right? So we simply return the result. Save the changes and we get 25. So you see, in modern JavaScript, we can achieve the same functionality with less code. Instead of defining a total variable, setting it to 0, and then looping over the arguments object, we can have one line of code that gives us the same thing. And this is more elegant and more professional. Now let's take this example to the next level. Imagine we're going to use this function to calculate the total cost of items in a shopping cart. Here, let's say we want to have a discount factor. So I'm going to add a parameter here, discount, and then rename args to, let's say, prices. So we're passing the price of all the items in a shopping cart. Now let's change line 8 where we call the sum function. Let's say we're going to pass 0.1 or 10% for the discount. And we have two products in our shopping cart with prices $20 and $30. So here, instead of returning the sum of all the items in the prices array, we're going to store the sum here in total. We don't need this anymore. And then we want to return total times 1 minus discount. So if discount is 0.1, we subtract it from 1, we get 0.9. Then we multiply it by the total, and this will return the final price after the discount is applied. Save the changes, so we get 45. Now let me show you something. I'm going to add one parameter after prices. Let's call that sum value. Now on line 7, where we call this function, let's pass a new value like 1. Save the changes. We get this error. Rest parameter must be last formal parameter. So we cannot have a parameter after using the rest operator. So here, prices is a rest parameter, so it should be the last parameter in a function. Let's remove this. And this is the reason we call this rest, because we can have 0 or more parameters before this. In this case, we have discount. So we have discount and the rest of the parameters or the rest of the arguments that are passed to this function. That's the reason this operator is called the rest operator. There are times that we want to supply default values to the parameters of a function. For example, let's imagine we want to write a function for calculating the total interest. So here we have 3 parameters: principal, interest rate, and years. And here's the formula to calculate the total interest. Principal times rate divided by 100 times years. Now, let's call this function. Let's imagine the principal is $10,000, rate is 3.5%, and we want to pay this back over 5 years. So let's log this on the console. So the total interest we have to pay is just over $1,700. Now, what if we want to have default values for the interest rate and the number of years? Well, earlier in the section about operators, I showed you a technique like this. So rate equals rate or 3.5. So if rate has a value, if it's truthy, we're going to use that. Otherwise, we're going to use 3.5. So we can use the logical OR operator to give a variable a default value. Similarly, we can set years to years or 5. With this, if we exclude these arguments, those default values will be used. So I'm going to delete these, save the changes, and you can see we still get the same result. But starting from ES6, we have a cleaner way to achieve the same thing. So instead of having these logical expressions, we can set the default values right here. So we set rate to 3.5 and years to 5. And now we can delete these 2 lines, save the changes, we still get the same result. So you can see setting the default value for function parameters is really easy. There is just one caveat here. Once you give a parameter a default value, you should also give all the other parameters after that a default value. For example, let's see what happens if we set the default value for rate, but not for the years. When we save the changes, we get not a number. Because we passed 10,000, so principal is 10,000. Rate is by default 3.5, but years doesn't have a value, so it's undefined. That's why the result of this expression is not a number. Now, what if we pass 5 for the years? Well, this is confusing for the JavaScript engine because it doesn't know if 5 should be used for rate or for the years. So if I save the changes, we still get the same result, not a number, because in this case, 5 is used for the rate, but years is still undefined. Now there is a trick around this, so we can pass undefined for the second parameter. And with this, rate will be set to 3.5 and years will be set to 5. Let's save the changes. Now we get the same result as before. But code like this is really ugly. Somebody looking at this code, they wonder, what is this undefined? They have to look at the function to figure out what parameter is associated with undefined. So as a best practice, whenever you want to give a function parameter a default value, make sure that that parameter is the last parameter in the list, or give all the parameters after that a default value. In this lecture, we're going to look at a special kind of methods in objects called getters and setters. So let's imagine we have a person object with two properties. First name, we set this to Mosh, and last name, we set this to Hamedani. Now, somewhere in our application, we want to display a person's full name. So we have to do something like this. Console.log, we can either get the person.first name, concatenate it with space, and then last name, or a better way, as I told you before, is to use a template literal. So we use the backtick, and then we add a couple of arguments here. So here's the first one. The argument is person.first name. Now we have a space, and here's the second argument, person.last name. However, the problem with this approach is that maybe there are multiple places in our application where we want to display someone's full name. With the current implementation, we'll have to repeat this template literal in multiple places. A better approach is to define a method in this object, call it full name, and move this expression right there. And then whenever we want to display a person's full name, we simply call that method. So we can add another key value pair, full name, but we set the value to a function. Or as I told you before, in ES6, we have a shorter syntax to add a method to an object. So instead of adding it as a key value pair, we can add it as a function without the function keyword. So if we want to define a function outside of an object, what do? We add function, the name of the function, parentheses, and curly braces. However, when we need to add this inside of an object, we just drop the function keyword. So you can see this new syntax is shorter and cleaner than the older syntax. Okay, so here's our full name method. We simply return this expression here. So I'm going to cut this and move it here. Now with this new implementation, every time we need to display someone's full name, we simply call person.fullname. Save the changes, we get Mosh Hamedani. Beautiful. However, there are a couple of problems with this approach. The first problem is that this is read-only. In other words, we cannot set a person's full name from the outside. It would be nice if we could do this, and then the first name and last name properties would be automatically set based on what we pass here. The other issue is that I don't like to call this like a method. It would be nicer if we could treat this as a property, so we could drop the parentheses like this. So how do we do this? Well, that's where getters and setters come in the picture. We use getters to access properties in an object and setters to change or mutate them. So in this object, we should add a getter, and with that getter, we can read this person's full name like a property, and with the setter, we can set it from the outside. So here is how it works. We prefix this method with the get keyword, and now this method is a getter. So we can access the full name like a property on line 15. Let me temporarily comment out this line. Save the changes. You can see our program is still working. Beautiful. So this is our getter. Now, to be able to set this from the outside, we need to add a setter. A setter is very similar. So we add the set keyword, the name of the property or method, and then code block. However, this method needs a parameter. We can call it value or anything. And the value of this parameter would be what we have on the right side of the assignment operator. So here, let's assume that value is a valid string. We need to split that string by a space, take the parts, and set the first name and last name properties. So value, we call the split method of strings. We want to split it by a space. This will return an array. We can call that parts. Now we can set the first name to parts of 0 and last name to parts of 1. And finally, instead of logging the person's full name, let's just log the person object. So initially, we set the first name and last name to Mosh Hamedani. Now with this new property, which is actually a setter, we're changing the name to John Smith. Save the changes. Here's our person object. You can see first name and last name properties are updated. Also, note that full name, its value is ... Sometimes when you're logging objects in the console, you may see properties with this kind of value. As you can see from the tooltip, this is a getter. In order to read the value, you need to click here. And now this method is executed and the result is returned in the console. So this is the benefit of getters and setters. In the next lecture, we're going to look at error handling. In the last lecture, we assumed that the value that we receive here is a valid string. But what would happen if we pass a Boolean here? That doesn't make sense, right? So let's run this code. We get this error, uncaught type error, value.split is not a function because split is a method that belongs to strings. Booleans don't have a split method, right? What would happen if we pass null or undefined? Save the changes, we get a different error. Cannot read property split of null. Again, for the same reason, we cannot call the split method on a null. It's only available on a string. So here we need to add error handling. Typically, in situations like this, we should do error handling at the beginning of a function or a method. This is what we call defensive programming. So we want to make sure that the values that are coming in are valid, they're in the right shape, so we can execute our logic. So the first line of this method should be something like this. We want to make sure that this value is a string. So we can use the type of operator. If type of value is not string, then one simple approach is to return. And with this, we'll no longer see this error message here. Save the changes so we can see the person object with the original first name and last name. So what we passed here, null, did not take effect. But sometimes we want to report an error in our application. That's where we need to throw an exception. Throwing an exception is a technical jargon that you might hear in a lot of programming languages. So let's see how that works in JavaScript. So instead of returning from this method, we use the throw keyword and then create a new error object. So new error, that looks familiar, right? So error is a constructor function because here we have the Pascal case and we're calling this function using the new operator to create a new error object, right? Now, as an argument, we can pass an error message. So value is not a string. So this is how we throw an exception. Now, some people confuse errors with exceptions, but there is a slight difference between the two. Here we can create an error object. Let's call that E, new error. This is just a plain JavaScript object. There's nothing special about this. But the moment we throw this error, we refer to that as an exception. So this is an exceptional situation that should not have happened. Okay? Now, in this method, we have some basic error handling. So this method is throwing an exception. Now somewhere else, we need to catch that exception. We need to catch that. And quite often when we catch an exception, we display an error to the user. So this is how we accomplish this. Line 15 is where we receive this exception. So we need to wrap this line in a try block. So try, remove this line here. So a try block can have one or more statements. One of these statements at least can throw an exception. Now, we add the catch block after. In parentheses, we give an identifier. This is the error object that we are throwing here. So in the catch block, we can get that error object and do something with it. So here, we can display it on the console. But as you know, this is only visible to developers, so an end user will not see this error. So temporarily, we can use the alert function. This is not something that I recommend you to do because that's a very old and poor way of reporting errors to users. The proper way is to display a label, perhaps a red label on the user interface. But that's a topic for a future video. So for now, let's just use the built-in alert function. Now, save the changes. And here's our alert. Value is not a string. Now let's take this to the next level. Instead of passing null, I'm going to pass an empty string. Save the changes. We don't get any errors, but first name is an empty string and last name is undefined. Again, that's not desirable. So ideally, we want to make sure that our user is typing a first name and last name. So when splitting that string, we can check the length of this array. So if part.length is not 2, that means something is missing. So here we can throw another exception, throw new error with a different message. Enter a first and last name. Okay, now save the changes. And here's our new exception, enter a first and last name. So basically, when we throw an exception, the lines after the throw statement are not executed. We'll jump out of this method and the control will move to the catch block. Here we catch the exception and do something with it. So this is the basic of error handling in JavaScript. In this lecture, we're going to talk about a very important concept called scope. So I'm going to define a constant called message and set it to high. Now let's log this on the console. So obviously we get high on the console. But what would happen if I add this message in a code block? Let's save the changes and see what happens. We get this error, uncaught reference error. Message is not defined. This is all about scoping. So a scope of a variable or a constant determines where that variable or constant is accessible. And when we declare variables and constants with let or const, their scope is limited to the block in which they are defined. So message is accessible in this block, but it's not accessible outside of this block. Now you might be wondering, why do we need this code block here? Well, this code block can be part of a function. So here we can have a function called start. And now we have a constant in this function. So because the scope of this constant is limited to the block in which it's defined, we cannot access this constant outside of the start function. The same is true when we declare a variable or a constant in an if block. So let's add an if block here. Some condition, we don't care. Let's declare another constant and set it to by. Now, this constant is only accessible in this block. If I go out of this block and try to log it on the console, we're going to get an error. So I'm going to remove the last line. Let's just call the start function. Save the changes. We get the same error, reference error. Another is not defined. We have the same concept in our loops. So let's define a for loop. Let I equal to 0. We're going to run it 5 times. Now, I is a variable that is only accessible in this block. So here we can log I. Let's save the changes. We get numbers 0 to 4. But if we go outside of this for block and log I, we're going to get the same error. Reference error. I is not defined. Now, let me simplify this code. So we're going to have a function with a constant called message. We can have another function. Let's call that stop. And in this function, we can have a constant called message with a different value. That's perfectly valid JavaScript code because the scope of this constant is limited to the block in which it's defined. So we can have 2 variables or constants with the same name, but in different functions. That's perfectly valid. Now, what if we define a variable or a constant outside of a function? So here I'm going to define a constant, color, and set it to red. Now here we don't have any code blocks. So what do you think is the scope of this constant? This constant has global scope. Global means this constant is accessible everywhere, globally. So we can go to the start function and log color, save the changes. You can see we have access to this constant color, right? So this constant is accessible in all the functions we have in our program. Now, what if we have a constant with the exact same name in our function? So let's take a look. I'm going to define this color constant, but set it to blue. What do you think we're going to see when I save the changes? Let's take a look. We get blue. So local variables or local constants in a function take precedence over global variables or constants. Now, in general, you should avoid defining global variables or constants. That is considered bad practice. Let me give you a metaphor. Imagine this is a toothbrush and each function is a person. You don't want to have a toothbrush that is shared between multiple people. Each person should have their own toothbrush. So you should avoid defining global variables or constants because they're accessible everywhere globally, and each function can accidentally change their value, and this will lead to all kinds of bugs and issues in our programs. So far, we have been declaring variables using the let keyword. But at the beginning of the course, I briefly mentioned that there is another way to declare variables using the var keyword. And you may see this in a lot of JavaScript code online. In this lecture, we're going to look at the var keyword. You're going to learn about the problems with the var and why you should avoid it. So let's start by defining a function, start. Here we're going to have a loop, let I equal to 0. We're going to run this loop 5 times. And in each iteration, we're going to display I on the console. Now let's call the start function, save the changes. So we get numbers 0 to 4. Now in the last lecture, you learned that I is only accessible inside this block. So if we try to log I outside of this block, we're going to get an error. I is not defined. Now I just want to clarify something. We still have the same concept if I remove this curly braces, because here we have a single statement. So the scope of I is still this block here. Okay, so save the changes. We still get the same error. However, let's see what happens when we replace let with var. Save the changes. What happened to our error? So it turns out that I is accessible outside of this for block. So in the last iteration, I becomes 5. Because 5 is not less than 5, so the loop terminates. And here on line 6, we're displaying the current value of I. So this is the issue with the var keyword. When you declare a variable with var, its scope is not limited to the block in which it's defined. It's limited to the function in which it's defined. And this is not how most or all programming languages out there work. It's one of those weird things in JavaScript that we have had for a long time. So before ES6, var was the only way to declare variables and constants. Starting from ES6, also called ES 2015, now we have 2 new keywords, let and const, to define variables and constants. These 2 keywords create block scoped variables, but var creates function scoped variables. Let's take a look at another example. So in this for loop, let's add a code block here. Now I'm going to add an if statement. Now in the if block, I'm going to declare a variable using var, color, set it to red. Now technically, in almost all programming languages out there, this variable should only be accessible in this block. But because we have used var, color is accessible anywhere in this function. So at the end of this function, we can log color, save the changes. Look, we get red here. But if we replace var with let, we get an error because color is not accessible here. And that's how most languages work. So this is the first problem with the var keyword. The second issue is with global variables. So let's delete all the code here. I'm going to declare two variables, one with var, color, we set it to red, and one with let. Let's say age and set it to 30. Save the changes. Now, when we use var outside of a function, this creates a global variable and attaches that global variable to the window object in browser. So in browsers, we have this window object, which is a complex object with lots of properties and methods. When you want to build front-end applications, you're going to work with this window object a lot. Now, what matters here is this var keyword attaches this color variable to the window object. So if we type window dot look, our color variable is here. In contrast, when we use the let keyword to define a global variable, that global variable is not attached to the window object. So if we type window.age, you can see it's undefined. So why is it bad to attach a variable to the window object? Well, because window object is something central, there is only one instance of the window object. And let's say you're using a third-party library. If that third-party library also has a variable with the same name, that variable can overwrite your variable. So you should avoid adding stuff to the window object. Otherwise, you're going to create all sorts of issues in your programs. Now, for a curious developer, I need to mention that when we define a function, let's say hi, this function is technically a global function and is added to the window object. So let me save the changes. If we type window.sayHi, see, our function is here, so we can call it. So technically, this is a global function. It's attached to the window object, and that is bad practice. But how can we prevent this? Well, later in the course where I talk about modules, you will learn how to encapsulate these functions in separate modules so they are not added to the window object. So here's what I want you to take away from this lecture. Avoid using the var keyword because it creates variables that are function scoped, not block scoped. In this lecture, we're going to have a closer look at the this keyword in JavaScript. This is one of those features that confuses a lot of developers, but honestly, I think it's because of the poor teaching materials out there, because I personally was confused about the this keyword for a long time. So in this lecture, I'm going to make it super simple for you so you can explain it to your 7-year-old brother. So what is this? This references the object that is executing the current function. Here, I'm going to give you a very simple rule of thumb. If that function is part of an object, we call that function a method, right? So if that function is a method in an object, this references that object itself. Otherwise, if that function is a regular function, which means it's not part of an object, this references the global object, which is the window object in browsers and global in Node. Let's take a look at a few examples. So I'm going to start by creating a video object. In this object, we're going to have a title property and a play method. Let's log this here and finally call video.play. Save the changes so we get our video object on the console. So in this example, because play is a method in the video object, this references this object itself. By the same token, we can add a method later in this object and we'll get the same result. For example, we can add a stop method here, set it to a function, and here we can do console.log of this. If we call the stop method, once again, we're going to see the video object on the console. So save the changes, and here is our video object. Because again, stop is a method in the video object. So that's an example of the first rule. Now let's take a look at an example of the second rule, a regular function. So let's delete this and instead add a function called play video. If we log this on the console, we're going to see the global object, which is window in browsers and global in Node. So let's call this function play video and save the changes. So we get the window object here. Now, what if this is a constructor function? We call the constructor functions using the new operator. So let's rename play video to video with a capital V. That's the convention for constructor functions. Now here we're going to pass a title property and set this the title to title. Now we can use this constructor function to create a new video object. So we use the new operator, save the changes. Oops, I forgot to pass a title here. That's the title. So what do we get here? Instead of the window object, we get a new object. Now note that this object is not this video object here. It's completely separate. To demonstrate this, I'm going to change this argument to B. So instead of the window object, we get this video object. Because earlier in the course, I told you that when you use the new operator, this new operator creates a new empty object like this and sets this in this constructor function to point to this empty object. So here on line 12, we add the title property to this new object. So let's recap. When dealing with a regular function, this by default references the global object. But if you call a function using the new operator, which is the case for constructor functions, this will reference a new empty object. Now, the last example. I'm going to clean up this code. Let's add another property in this object, tags. We set it to an array of 3 strings. Now let's rename the play method to show tags. So here we can use this to get the current object and then get the tags property. Because this is an array, we can call the for each method. And here we need to pass a callback function. So function. In each iteration, this function will get a tag, and then we can display the tag on the console. So console.log of tag. Finally, let's call video.showTags. Save the changes. So we get A, B, C. Beautiful. But what if we want to display the title of the video next to each tag? Well, we can add this, the title here, save the changes. We got undefined. What's going on here? Well, let's remove the title property and see what this is referencing. Save the changes. It's referencing the window object. But aren't we inside a video object here? Shouldn't this reference the video object? No, because here we are inside this callback function. This function is just a regular function. It's not a method in the video object. The only method we have here is show tags. So because this is a regular function, this references the global object. So it's the global object that is executing this anonymous callback function. But how can we solve this problem and display the title of the video next to each tag? Well, we have a few different solutions for this. In this particular case, the for each method has 2 parameters. The first parameter is our callback function. The second parameter is this arg. So we can pass an object here, and this will reference that object. For example, here I can pass a new object with the first name set to Mosh. Now, when we save the changes, you can see this is referencing this new object. Now, in this example, we don't really want this object. We want our video object. So we can pass this here. Because at this point, we are in the show tags method. So this references the current object. So here we are not inside of a callback function. We're still in the execution context of the show tags method. So now if we save the changes, next to each tag, we can see our video object with this title property. So we can add the title property here. And with this, we see the title of the video next to each tag. Beautiful. But not all methods in JavaScript give you the ability to pass this argument. So we have a few different solutions for that, and that's the topic for the next lecture. So in the last lecture, you learned that this references the object that is executing the current function. All right, now let me show you a few different solutions to change the value of this in a function. So let's imagine our for each method doesn't have this second parameter. How can we change the value of this? Well, here is one simple solution. Before we call the for each method, we can define a constant, call it self, and setting it to this. Some people also call this that. It's more of a personal preference. There's no right or wrong. So let's call this self. Now at this point, self is referencing the video object here. So in our callback function, we can use self instead of this because the value of this changes when a new function is called. So at this point, this references the video object, but when we get to this callback function, this references the global object. So here we can use self, which is the original value of this, save the changes, and we get the title of the video here. Beautiful. Now, this is not the preferred approach, but it's something that you see in a lot of JavaScript applications out there. So I just want you to understand it, but don't use this approach. Now let's take a look at another approach. Earlier in the course, you learned that functions are objects in JavaScript. So let's define a function, call it play video. Here we do a console.log of this. So this function is technically an object. So it has properties and methods that we can access using the dot notation. Here we have three methods: apply, bind, and call. And with these, we can change the value of this for this function. The simplest is the call method. The first parameter of this method is this arg. So here we can pass an object, and this will reference that object. For example, I can pass a new object with the name property set to Mosh. Now, when we save the changes, we're going to see this object on the console. But before we get there, let me temporarily comment out this previous code. So save the changes. You see this new object. In contrast, if we call this function using the standard function call syntax, this references the window object. So this is the benefit of using the call method. We have another method that is similar to call, and that is called apply. So let me duplicate this line, change this to apply, save the changes. Again, we get the same result. So what we pass as the first argument here will be used as the value of this. The difference between call and apply is only about passing arguments. So if this function has multiple parameters, let's say a and b, we can supply multiple arguments here, 1 and 2. But with the apply method, we have to pass them as an array. So 1 and 2. That's the only difference. We have another method that is bind. So play video.bind. Once again, the first argument is this arg. So we can pass this object name Mosh. But this bind method does not call our play video function. It returns a new function and sets this to point to this object permanently. So no matter how we call that function, this will always point to this object that we pass here. So this returns the new function. We can store the result in a constant and now call this function just like a regular function. Save the changes. Once again, we get this new object here. Now, in this particular case, we don't really need this separate constant. We can delete this and immediately call the function that is returned from the bind method. Save the changes, we get the same result. So with call, apply, and bind, we can set this argument for a given function. Now, let's go back to our previous example. So let's delete all this code here. Back in the show tags method. So here we're passing this callback function, and in this function, we're going to use this. So we no longer need the self constant. However, as you know, by default here, this references the global object, but we want to change this. So here we have a function. We can call the bind method immediately here, and then pass an object to be used as the value of this. What should we pass here? This. Because as I told you before, at this point, we are in the show tags method. So this references our video object. So save the changes. And once again, you can see the title of the video next to each tag. So using the bind method is the second solution to solve this problem. But there is a newer and better solution. Starting from ECMAScript 6, we have arrow functions. The good thing about the arrow functions is that they inherit the this value. Let me show you what I mean by that. So let's remove the call to the bind method and change this function to an arrow function. So we remove the function keyword, put a fat arrow between the parameter and the body, and because we have a single parameter, we remove parentheses. Cleaner syntax. Now if you save the changes, we still get the same result without doing anything extra. The reason for this is because arrow functions inherit this from the containing function. So in this function, this references the video object. So when we pass an arrow function here, the same this value is used in this arrow function. In other words, this is not rebound to a new object. So let's quickly recap. In this lecture, you learned about 3 ways to change the value of this. The first solution was using the self approach. So the second solution was using the bind method. So right after defining this function, we call bind and pass this as the argument. But again, this is the old way of doing things. It's a little bit noisy, but you may still see it in a lot of JavaScript applications out there. So going forward, the modern approach to solve this particular problem when dealing with callbacks is to use an arrow function. Now it's time to practice what you have learned in this section. So here's your first exercise. I want you to create a function called sum that takes a varying number of arguments and returns their sum. We can pass 1 argument or 2 or 3 or more. So here we should get 10. So do this first, and then to challenge yourself, modify the sum function to be able to accept an array and still return the same result. Now, as part of this challenge, you need to detect if the argument that is passed is an array. To do that, we use array.isArray method. So let me show you how this works. We can call array.isArray. If we pass an array object, we get true. If we pass anything else, like a regular object, we get false. So pause the video. When you're done, come back, continue watching. All right, let's create this function called sum. Now to have a varying number of parameters, we use the rest operator. So ... items. Now we can pass as many arguments as we want, and this spread operator will convert them all to an array. So we have an array. To get the sum of items in an array, we can use the reduce method. So items.reduce, we pass an arrow function, a and b goes to a plus b. And finally, we return the result. Now let's call this function. So console.log of sum of 1, 2, 3, 4. Save the changes. We get 10. Beautiful. Now let's work on the challenge. So if we pass these arguments in an array, with the current implementation, instead of getting 10, we get the array itself. Let's see why this is happening. So in this function, I'm going to log items, save the changes. So items is an array of arrays. Look, here we have an array, and the first element in this array is this array of numbers. Because I told you that the rest operator converts whatever we pass here into an array. So because we're passing an array of 4 numbers, this rest operator would put this array inside of another array. And that's why we don't get the sum of these arguments. How can we solve this issue? Well, we need to check to see if this items array has a single element and the first element is an array itself. So we can do something like this. If items.length equals 1, and we want to see if the first item is an array. So array.isArray, we pass items of 0. If that's the case, we need to flatten this structure. So instead of having an array of arrays, we want to have just an array of numbers. How do we do that? We use the spread operator. So we reset the items to a new array, and we use the spread operator to spread items of 0, which is another array. That's the array we have here, right? Now, let's save the changes. We get 10, beautiful. So we can pass an array to our function or individual arguments, and either way, we get their sum. This second exercise is pretty easy. It's just to help you get used to the syntax. So I want you to create a circle object using the object literal syntax. Now this object should have a radius property that we can read or write to. For example, we can set circle.radius to 2. It should also have an area property that is read only. So we should not be able to set the area from the outside, but we should be able to read it. For example, we can do a console.log of circle.area. So spend a couple minutes on this exercise. You can see my solution next. All right, so let's declare a circle object. We can give it a radius initially. Now to create a read-only property, we need a getter. So we use the get keyword. Here's the name of our property, but it's implemented as a method. Now here we need to return math.py times this.radius times this.radius. Okay? And finally, we can do a console.log of circle.area. Save the changes. So this is what we get if we change radius to a new number and then read the area. We get something different, but we cannot set the area from the outside because this is a read-only property. We don't have a setter here. Now to prove this, even though here I set the area to 20, if I read it again, you can see it has the old value that is computed based on this formula. Earlier in the course, in the section about arrays, we had this exercise to count the number of occurrences of a given element in an array. So this is the solution we wrote for this exercise. If you don't have this, download the source code for all the exercises for this course. You can find this at the beginning of the course in the first section. So in this project, if you look in the arrays folder, the 5th exercise, count occurrences. So I copied that code into index.js to use for this exercise. Now, this function has a tiny problem. Here we're assuming that the first argument is a valid array. What happens if we call this function with a Boolean? We get this error, uncaught type error. Array.reduce is not a function because here we're calling array.reduce and Booleans don't have this reduce method. The same happens if we pass null or undefined or a number. When we pass null, we get a different error. Cannot read property reduce of null. So here we need to modify this function and add error handling. So this is what I want you to do for this exercise. If this first argument is not an array, I want you to throw an exception. Then wrap these 2 lines with a try-catch block. You can also wrap these entire 3 lines all together in a try-catch block. It doesn't really matter. One of these lines is going to throw an exception. That is the second line, the call to count occurrences function. So there, catch the exception and log it on the console. Again, very simple exercise. It just helps you get used to working with exceptions. You will see my solution next. So in this function, first, we need to validate the first argument. Earlier, you learned about array.isArray method. So we can pass this first argument here. And if this is not a valid array, we want to throw an exception. So throw new error, invalid array. You can add any error messages here. It doesn't really matter. Now, we want to wrap this code in a try-catch block. So try We put these 3 lines there, and then catch. Here we add an identifier for our exception, the error object that we are throwing here. We get that and display its message property on the console. Save the changes, and here's our error message.